India's foray into space research started in the early 1960s, when satellite applications were in the experimental stages worldwide. After witnessing the importance of space science, Dr. Vikram Sarabhai, the visionary behind India's space program, quickly realized the application of space technologies for India's mass communication. He had a strong conviction and a visionary outlook, recognizing that the vast resources in space would tackle the real problems of society in the country. He gathered a team of exceptionally talented and highly skilled people, including scientists, anthropologists, communicators, and social scientists from all over the world to lead the Indian space program. In order to lead the space research activities, the Indian National Committee for Space Research, INCOSPAR, was established in 1962 within the Department of Atomic Energy. Following that, the Indian Space Research Organization, ISRO, was founded in August 1969, replacing INCOSPAR. In June 1972, the Government of India formed the Space Commission and established the Department of Space, or DOS. Later, in September 1972, ISRO was brought under the DOS. The prime objective of ISRO, DOS, is the development and application of space technology for various national needs. With the objective of achieving this goal, ISRO has developed significant space systems for communication, television broadcasting, and meteorological services, as well as resource monitoring and management and space-based navigation services. ISRO has successfully developed satellite launch vehicles, namely PSLV, GSLV, and LVM-3, which are specifically designed to precisely position satellites in their designated orbits. ISRO functions through various centers and units located across the country. The headquarters is located in Bengaluru. Vikram Sarabhai Space Center, VSSC, Thiruvananthapuram, is the lead center for developing launch vehicles. Satellites are meticulously crafted and engineered at the U.R. Rao Satellite Center, URSC, in Bengaluru. The payloads and applications are designed and developed by Space Applications Center, Ahmedabad. Satish Dhawan Space Center, SDSC Shar, Sriharikota, is the second best launch port in the world and houses the solid motor production and test facilities and the launch base infrastructure. The assembly and integration facilities, launch pads, satellite preparation, tracking and telecommand systems are part of the launch complex. The development of liquid stages and cryogenic stages is carried out at the Liquid Propulsion Systems Center, LPSC, in Valiamala and Bengaluru. IPRC has cutting-edge assembly, integration and testing facilities for qualifying the liquid, semi-cryo and cryo stages. ISTRAC, located in Bengaluru, is entrusted with the responsibility of providing tracking support for all the satellites and launch vehicles. Master control facilities at Hassan and Bhopal will take control of satellites after injection and subsequent maneuvers of Earth observation satellites and continuous monitoring of communication satellites in the orbit. The National Remote Sensing Center, NRSC, in Hyderabad is responsible for the reception, processing and dissemination of data for remote sensing satellites. ISRO has launched several Earth observation satellites, namely Cartosat, RISAT, ResourceSat, and OceanSat for various applications in the geospatial domain and continuously provide satellite data applications to various user ministries and other users. ISRO also launched a fleet of conventional and high-throughput satellites in the geosynchronous orbit, which extends broadband, mobile and weather-related services to the users. NAVIC is the navigation system of India, with a constellation of satellites launched in geostationary and geosynchronous orbits to meet the position, navigation and timing services for various users, including strategic. ISRO also created records in the interplanetary missions like Mangalyaan and Chandrayaan. ISRO space mission AstroSat, Aditya L1 and ExpoSat have been contributing immensely for the space research community through various research institutions across the country. The satellite data has been consolidated by ISRO and made available to various users through platforms like Bhuvan, Mosdak and Vedas. Several government and private users are deriving benefit out of these portals. ISRO is constantly and continuously contributing to the capacity-building space infrastructure and human resources in the country through various sponsored R&D programs and outreach activities. From its modest origins, ISRO has today emerged as a leading space agency on the global stage. In addition to serving the nation and its citizens, it endeavors to nurture scientific inquisitiveness within the Indian society.
Good morning. Secretary will be reaching in 15 minutes, so we'll start the program in 15 minutes. Sorry for the delay.
Rarest visit of Red Planet. ISRO's first ever interplanetary mission, Mangalyaan, successfully visited Mars on its maiden voyage. On September 24, 2014, India garnered international recognition for successfully inserting the Mars Orbiter mission, MOM, into Mars orbit on the first try.
हमारे वैज्ञानिकों का पुरुषार्थ था कि मंगलयान की सफलता और पहले ही प्रयास में सफलता विश्व के अंदर हमारे लोग मंगल के कक्षा में प्रवेश किया, वहां तक पहुंचे, ये अपने आप में हमारे वैज्ञानिकों की सिद्धि थी.
Despite the fact that this feat has previously been accomplished by advanced space agencies multiple times over, it's the fourth country to reach Mars orbit. After leaving Earth, the spacecraft MOM covered 650 millions of kilometers in her 300-day journey to Mars. The success of the mission, in the words of Honorable Prime Minister,
आज मॉम का मंगल से मिलन हो गया. आज मंगल को मॉम मिल गई.
ultimately, it completed 7 years of mission life despite being designed for 6 months. India's ability to send spacecraft into interplanetary space was demonstrated by this mission. Rarest visit of Red Planet. ISRO's first ever interplanetary mission, Mangalyaan, successfully visited Mars on its maiden voyage. On September 24, 2014, India garnered international recognition for successfully inserting the Mars Orbiter mission, MOM, into Mars orbit on the first try.
हमारे वैज्ञानिकों का पुरुषार्थ था कि मंगलयान की सफलता और पहले ही प्रयास में सफलता विश्व के अंदर हमारे लोग मंगल के कक्षा में प्रवेश किया, वहां तक पहुंचे, ये अपने आप में हमारे वैज्ञानिकों की सिद्धि थी.
Despite the fact that this feat has previously been accomplished by advanced space agencies multiple times over, is the fourth country to reach Mars orbit. After leaving Earth, the spacecraft MOM covered 650 millions of kilometers in her 300-day journey to Mars. The success of the mission, in the words of Honorable Prime Minister,
आज मॉम का मंगल से मिलन हो गया। आज मंगल को मॉम मिल गई।
ultimately, it completed 7 years of mission life despite being designed for 6 months. India's ability to send spacecraft into interplanetary space was demonstrated by this mission.
The moon, a well-known visible object in the night sky, has captivated the minds of both scientists and common people. The charming allure of the moon has enchanted people throughout history. Scientists believed the moon would reveal the mysteries of the solar system and our own planet Earth. This mysterious puzzle has fueled numerous expeditions to our celestial neighbor. India achieved a significant milestone in space exploration when Chandrayaan-1 was successfully launched on October 22, 2008. The spacecraft carried a total of 11 scientific instruments. It orbited around the moon at a height of 100 kilometers from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. With the suggestion of former President Dr. APJ Abdul Kalam, ISRO achieved a remarkable feat by creating the Moon Impact Probe, which became the first Indian object to touch the lunar surface. This accomplishment is a testament to India's innovative approach and dedication to space exploration. The presence of water, H2O, and hydroxyl, OH, on the lunar surface was a groundbreaking discovery of the Chandrayaan-1 mission and opened up new possibilities for lunar exploration. The follow-on mission, Chandrayaan-2, was successfully launched on July 22, 2019 by the ISRO's heavyweight LVM-3 M1 launch vehicle. The Chandrayaan-2 satellite was made up of orbiter, lander Vikram, and rover Pragyan. The orbiter is still healthy and continuing its observations about the lunar surface. The suite of orbiter payloads with unique capabilities is offering valuable insights into the lunar surface, providing a plethora of information to the scientific community and conducting a comprehensive analysis of the moon's topology. The Chandrayaan-2 mission paved the way for Chandrayaan-3's soft landing on the lunar surface. On July 14, 2023, ISRO's heavyweight launch vehicle, LVM-3 M4, successfully launched the highly anticipated lunar mission Chandrayaan-3. The Chandrayaan-3 integrated module is configured with a propulsion module and a lander module with the rover housed within the lander. The lander module of the Chandrayaan-3 has been enhanced to ensure greater durability and resilience, surpassing the capabilities of the Chandrayaan-2 module. It has been reinforced to independently adapt to a wider range of variables, enabling a safe and soft landing. Detailed tests have been carried out for the performance evaluation of the lander systems on Earth to ensure the capability of lander for autonomous, safe and soft landing in all possible conditions. The propulsion module comprised a payload called spectropolarimetry of habitable planet Earth, SHAPE. This payload was designed to discover how smaller planets in reflected light would allow us to probe into a variety of exoplanets which would qualify for habitability. The lander module was equipped with 4 payloads, namely radio anatomy of moon-bound hypersensitive ionosphere and atmosphere. RAMBA was used to measure the near-surface plasma density and its changes with time. Chandra's Surface Thermophysical Experiment, CHAST, carried out the measurement of thermal properties of lunar surface near polar region. Instrument for Lunar Seismic Activity, ILSA, measured the seismicity around the landing site and delineating the structure of the lunar crust and mantle. Laser Retroreflector Array, LRA, was a passive experiment to understand the dynamics of the Moon system. The rover module was equipped with 2 payloads: Laser-Induced Breakdown Spectroscope or LIBS did qualitative and quantitative elemental analysis and derived the chemical composition and infer mineralogical composition to further our understanding of the lunar surface. Alpha Particle X-ray Spectrometer, APXS, determined the elemental composition of the lunar soil and rocks around the lunar landing site. The LVM-3 rocket successfully deployed the Chandrayaan-3 satellite into an elliptical parking orbit at a distance of 170 by 36,500 kilometers. Following the sequence of Earth burns or EBN, the spacecraft was precisely inserted into translunar orbit. On August 5, 2023, Chandrayaan-3 successfully entered the lunar orbit at an intended distance of 164 kilometers by 18,074 kilometers. Then the spacecraft achieved a lunar orbit of 153 kilometers by 163 kilometers through a series of lunar burns. On August 17, 2023, the lander module was successfully detached from the propulsion module. After a series of maneuvers, the lander module was successfully brought into a 25-kilometer by 134-kilometer lunar orbit. Consequently, the lander module initiated the power descent phase to achieve a soft landing near the south pole of the lunar region. Then, the much-anticipated spacecraft landing on the lunar surface had begun. On August 23, 2023, the long-awaited Chandrayaan-3 spacecraft achieved a successful soft landing on the Moon. The entire country witnessed the event and cherished the triumphant occasion. The entire nation was filled with pride as they witnessed the relentless efforts of the Indian Space Research Organisation. The Honourable Prime Minister, Shri Narendra Modi, witnessed the triumphant event through virtual mode and applauded the valiant efforts of the ISRO scientists.
चंदा मामा बहुत दूर के हैं, चंदा मामा बहुत दूर के हैं, अब एक दिन वो भी आएगा जब बच्चे कहा करेंगे चंदा मामा बस एक टूर के हैं.
On August 24, 2023, rover ramped down from the lander and India embarked on a historic moonwalk. After coming back from South Africa and Greece, the Honourable Prime Minister promptly headed to the ISRO Telemetry Tracking and Command Network, ISTRAC, in Bengaluru on August 26th. During his visit, he expressed his admiration and delivered a historic speech about the achievements of ISRO scientists and the lunar mission Chandrayaan-3. He also saluted the pivotal contribution made by the women scientists of ISRO, the Nari Shakti in the successful accomplishment of India's lunar landing mission. By achieving this historic feat, he has given it the names
चंद्रयान 2 के पद चिन्ह जहां है, वो स्थान आज से तिरंगा पॉइंट कहलाएगा। और जहां पर चंद्रयान 3 का मून लैंडर पहुंचा है, वो स्थान आज से शिव शक्ति पॉइंट कहलाएगा।
to commemorate the grand success of Chandrayaan 3. The Government of India announced
23 अगस्त को जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
to honor India's amazing space exploration journey. Govt, in collaboration with ISRO, conducted the Chandrayaan 3 Maha Quiz, in which millions of students participated. The remarkable achievement of Chandrayaan 3 highlighted India's impressive technological advancements, scientific expertise, and unwavering dedication to the exploration of outer space. India's success will further strengthen its position in the global space community. The success of this mission will ignite a sense of pride and inspiration in future generations.
A very good morning to all the esteemed dignitaries, colleagues, and dear students. I welcome all of you to this star-studded occasion. Last year, with the ginormous feat of landing Chandrayaan 3 Vikram lander, India has become the first country to land near the moon's south pole. To mark this special day in the history of Indian space program, August 23rd has been declared as the National Space Day by the Government of India, with the theme of this year being Touching Lives While Touching the Moon, India's Space Saga. Today we have an exciting lineup of talks, presentations, and panel discussions, all aimed at inspiring curiosity and passion for space among people, especially the youth of India. To start this event, I would like to invite former Secretary DoD, Dr. Harsha Gupta, on dais. Director NIAS Padma Shri, Dr. Shailesh Nayak. Secretary MOS, Dr. M. Ravichandran. Director NRC, Dr. Prakash Chauhan. And Director Inquires, Dr. Tri Srinivas Kumar. I request our Director Sir to present a gesture of welcome to our esteemed guests on the dais. Thank you so much, sir. I cordially invite our esteemed guests on the dais to come forward and illuminate the lamp to inaugurate this workshop. Thank you so much, sirs. I would like to invite the Director Inquires to deliver the welcome address.
Thank you, Sneha. Very good morning and welcome to all of you to Inquires for this very important event. I would like to take this opportunity to invite, welcome to Inquires, Professor Harsh K. Gupta, former Secretary of the Department of Ocean Development. Welcome, sir. And I would also like to invite our keynote speaker of today, Dr. Shailesh Nayak, who was the former Director of Inquires and also the former Secretary of the Ministry of Earth Sciences. I would like to invite also our beloved Secretary to Ministry of Earth Sciences, Dr. M. Ravichandran, to Inquires. He also was with Inquires, for 15 years. He was with us, leading us several of the activities at Inquires. I'd like to invite my good friend, Prakash, Director of the National Remote Sensing Center, also to Inquires, and then several dignitaries of the dais, speakers of today. We have Dr. Mahapatra, DG IMD, Dr. Mishra, Dr. Prasad, Dr. Tampan, Dr. Bala, and several of my colleagues, Dr. G.S. Rao, Neeraj. I see several colleagues Dr. Thomas, all of you actually, and all media colleagues, and then students who are amongst the gathering, colleagues from INCOIS, industry participants especially. We have a lot of colleagues who have come from the space tech industry. I invite all of you to INCOIS. A very good morning. I'm happy to have all of you today at INCOIS. As Sneha explained, just in her opening remarks, we are actually going to have our National Space Day. The maiden Space Day is going to be celebrated on 23rd August. And you all know that Honorable Prime Minister Shri Narendra Modi ji has announced this 23rd August as the Space Day, commemorating our successes in the space program. ISRO successfully soft landed on the moon through the Chandrayaan-3 mission. And then this is what we are actually celebrating, those achievements, and then trying to see where we can move forward in our space saga. To raise the visibility of this, of space in our broader community, broader public, and then amongst the researchers, amongst the research institutions, amongst the students. So we are actually, celebrating this Space Day. And aptly actually titled, it's actually touching lives while also touching the moon. That has been, the central part of the space program. And as you see, INCOIS is a very standing and shining example of how space tech can be used to benefit the society. So it's very apt that INCOIS is hosting this together with NRSC, this event in the run-up to several other events hosted by other institutions all across the country in the run-up to the maiden Space Day on 23rd. So we are happy that due to our experience in using space technology for several applications, we are happy to host this program. In fact, INCOIS has been institutionalized of the need for services that can be provided to coastal and ocean users. And then it started off at NRSC as a joint project between the then Department of Ocean Development and ISRO, bringing the benefits of space to the fishermen. That was how the INCOIS started. And today we have several services that we offer to several stakeholders. We actually address different parts of the value chain, touching the lives of fishermen, ports and harbors, the Navy, coast, strategic users, anybody, oil and natural gas, energy sector users. So they need several services as far as the oceans and coasts are concerned. Disaster management services, you talk about the states, coastal states, all of them use our services actually. And then at some point at the start, you will certainly see that space plays a very important role in actually developing these services. Like I spoke about the fishermen services, then we provide information to actually fishermen and other stakeholders on not only where to go for fishing, but then how safe is it to go or navigate to those locations through the ocean state forecast. We provide information on tsunami early warnings, storm surge early warnings. This system was set up in 2000, after the 2004 Indian Ocean tsunami, and now we are actually warning system that provides warnings not only to the country, but the entire, Indian Ocean region. And you'll see that actually we work on ocean observations, ocean modeling, ocean forecasting, and delivering these services. We provide information, for example, say on harmful algal blooms, which uses satellite data. We provide information on algal bloom information system, which uses satellite data. Tsunami warnings, you can use altimeter data for detecting tsunamis. So there are several applications across with sensors operating across the entire electromagnetic spectrum, starting from visible radiometers to thermal infrared radiometers to altimeters to scatterometers to synthetic aperture radars, which we use. And INCOIS is one of the prime users of the OceanSat-3, which has been launched by ISRO, where the data from the ocean color monitor, the scatterometers is used for various applications spanning weather, spanning oceans, spanning coasts, spanning cryosphere. So there are all these applications which you're going to hear over the day today, over the half day that we are going to have here. We have students, like I mentioned. We are having student competitions that are being held parallelly, ideathons, and then the painting competition. So we want to engage a large group of stakeholders in this whole event and see how we can benefit, how we can work together to make sure some of these applications can, we can develop new applications and then take the space science forward to meet the requirements of the society. So with these few words, I would like to thank all of you for coming here and thank all the dignitaries on the dais and off the dais for being with us today, and then look forward to very fruitful deliberations, especially the industry partners. We are looking forward to a fantastic panel discussion. Thanks for agreeing to be on the panel here. So we look forward to working with you more and more, and also with the students. Thank you very much, and welcome to INQOIST once again.
Thank you, sir, for your welcome address. Now I call upon Director NRSA, Dr. Prakash Chauhan, to deliver his keynote address.
Namaskar, good morning to you all. Most respected Dr. Shailesh Naik sir, Professor Harsh Gupta ji, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, friend Srinivas ji, Director of INQOIST, other senior directors and functionaries of Ministry of Earth Sciences, my colleagues from National Remote Sensing Center, Space Application Center, and all colleagues of INQOIST and those who are joining this program in online mode, my greetings and warm welcome to this National Space Day event, which Ministry of Earth Sciences is celebrating along with National Remote Sensing Center, Department of Space, on this day of August 6. It's a very important day over here, as Srinivas told that, last year on August 23rd, India landed, successfully on the southernmost part of the moon, and that became a history. Many of you must have witnessed that event live, and it was basically not only an event which was watched keenly in India, but throughout the world. In fact, that event, a scientific event which basically became so popular that it broke all the viewership record on the YouTube, which is unprecedented and rare. So to celebrate that success of Indian science, our Honorable Prime Minister basically suggested and declared that this day should be celebrated as National Space Day every year. And we are going to have a big celebration on 23rd of August in New Delhi at Bharat Mandapam program. But nonetheless, at the same time, various ISRO centers, along with different science ministries, are also celebrating, the pre-event programs at different locations. Here in this region, NRSE is celebrating almost 1 dozen programs, and this program is also one part of that series where we are collaborating with INQOIST and Ministry of Earth Sciences to commemorate that success of Indian science. The theme of this year's topic is also very apt. The touching lives while touching the moon. This success, especially for the younger people, you may be recalling the recent success, but success doesn't come just like that. It's the hard work of last more than 5 to 6 decades for Indian space program. Dr. Shailesh Naik is sitting over here. He was my mentor and guru at Space Application Center. In fact, the first day I landed at Space Application Center, I joined with Dr. Shailesh Naik. That was the day when Dr. Vikram Sarabhai, he's had a vision for India's space program when the space journey started. And people questioned the relevance of space program in those days, not so financially strong India. And the argument which was put forth that the space activity at that time, he told, and the famous quote is there, that we are not supposed to compete with the so-called international players of those world, but the vision of the Indian space program to help the common man of these countries. And that, if we look back in hindsight, it has truly come true. Today, space is being used in all sectors of economy, socio-economic empowerment, as well as bringing the financial inclusivity of the country. If you are making banking transactions, it is being done through communication series of satellites of India. If you are navigating and coming to INQOIST from your university or colleges through a navigator, this also, the space technology, either in terms of a GPS constellation or our own Navi constellation, is helping you to navigate on the surface of Earth. He talked about various applications like fisheries, disaster management, agriculture, climate change studies. You talk any sphere of life, today space data is being used in an extensive manner. Last year, 2 years back, in fact 2021, 22 onwards, a series of reforms has also been set up by Government of India, especially by bringing the National Geospatial Policy as well as the Space Policy 2023, which basically aims for wider inclusion of Indian private sector as well as public sector for developing the space economy in a big way. Currently, India is only contributing around 2% to the global space economy. And the vision of the Government of India is that by 2047, or even much before than that, we should be able to contribute at least to the 10% of the global space economy. And it cannot happen only by one Department of Space or some 18,000 plus scientists, engineers in ISRO. And that's why if we have to scale it up, the space activity and space economics in India, the private sector participation is must. And let me tell you, friends, that in last 2.5 years, almost more than 200 startup companies have started space activity in India, which is unprecedented. And that tells us the power of Indian youth and the ecosystem which we are building as to encourage the science and technology in this country. And it's also very heartening to tell you that we are sitting in Hyderabad, and the maximum of those startup companies are there in Hyderabad. So I think for that we need to clap for Hyderabad at least. If you walk around here, you will find a company or a set of companies which are developing the advanced rocket systems. You are having companies which are developing satellite systems. They have firm contracts from various countries also to develop and launch satellites. And of course, you have the presence of National Remote Sensing Center, which is also going to celebrate its 5 decades of journey. This is the golden jubilee celebration for NRSC. NRSC was established in 1974. And that time, the governing board chair was Prime Minister of India, Mrs. Indira Gandhi. That was the importance of NRSC, which was given by government. It was basically with DST at that time. Later on, it moved to Department of Space. And Hyderabad, near to Shamshabad, there is a place called Shadnagar, was the first place in India where a ground station was established in 1979. So the journey of space activity started since then and we started receiving the Landsat and other American satellite data here in Hyderabad itself. So the role of Hyderabad as a city in India's space journey is tremendous. And I am very thankful to Secretary Ministry of Earth Sciences, Ravi Chandran Saab, for bringing this function, which is being organized by MOES along with ISRO, to Hyderabad to commemorate the National Space Day. I welcome once again each one of you. There is a beautiful exhibition also which we have set up outside. And INCOIS is the biggest beneficiary of the space activity. Srinivas already talked about it. We are also having Mahapatra ji, who is also a very important stakeholder for our INSET program. And recently we have launched INSET 3D, the next generation satellite, which is also now is providing its services to the country. And thanks to some of these satellites like INSET 3D, 3DR, 3DS, as well as a scatterometer series of satellites, large amount of data is flowing into our operational weather forecasting activities. And of course, for various other earth science activities also, today space data is being used extensively in the different Ministry of Earth Science and other organizations. I wish this particular function a grand success, and I'm sure that today's deliberation will enlighten all the youngsters, and we are also having a continued program to support the Ministry of Earth Science activities, and you will come to know through technical sessions about the details of this program. Thank you very much for coming over here, and wish you all the very best.
Thank you, sir. Thank you very much for sharing your experience, knowledge in the space technology in various Earth system science applications. Next, we have opening remarks by Dr. Nilesh Desai, Director SAC, presented as a pre-recorded video clipping.
Good morning. It is heartening to note that Ministry of Earth Sciences and INCOIS in collaboration with National Remote Sensing Agency of ISRO is celebrating the first National Space Day at Hyderabad. at INCOIS. And I am happy to be part of this inaugural program today on the eve of the National Space Day celebrations at INCOIS, Hyderabad. It is great to be in the company of stalwarts like Dr. Sailesh Naik sir, Dr. Ravichandran sir, my dear friend Dr. Prakash Chauhan, and Sri T. Srinivas Kumar, Director in COIS. And I am thankful to all of you for inviting me to take part in this inaugural program. Of course, I apologize for not being able to be physically present due to other engagements, but I am virtually present, and I am thankful to all of you for giving me this opportunity to address the gathering on the inaugural function. As far as this National Space Day celebrations are concerned, this is the first time we will be celebrating the landing of Chandrayaan-3 on the south pole of moon, and it is of course a very eventful occasion for our country. It mobilized the whole country and motivated all our young students as well as we all scientists on that historic day of 23rd August 2023. But the activities which ISRO does as a part of its space exploration and planetary missions like Chandrayaan or Mangalyaan and now Gaganyaan related activities, they are just 20% of the activities which we all do as a part of our national space endeavor. The rest 80% of activities are the activities in which ISRO has been trying to fulfill the vision given by Dr. Vikram Sarabhai about using the space research and technology for the benefit of common man and society. And in fact, we have been working in association with Ministry of Earth Sciences to achieve this goal, the vision given by Dr. Vikram Sarabhai. During last decade, we have witnessed a quantum improvement in the weather and ocean state forecasting capabilities in India. The weather forecasts today are very accurate and location specific rather than general and large scale weather outlooks issued few years back. The cyclone and associated storm surge predictions are provided almost a week in advance, and that gives a sufficient time for national disaster management agencies to take timely actions and reduce the risk to save many lives and minimize the infrastructural damage in our country. It is also a well known fact that satellite technology has played a major role in this, thereby strengthening the vision given by Dr. Vikram Sarabhai regarding the usage of space research and technology to contribute to the welfare of our society as well as common man. As I mentioned earlier, the Indian space program has contributed immensely toward the various endeavors of Ministry of Earth Sciences to improve the forecast for weather and ocean state. Starting with our first experimental satellites Bhaskara 1 and Bhaskara 2 during 1979 to 1981 time frame, where we had a microwave radiometer as well as TV camera to provide various informations. Those were the early days, and these were followed by the INSAT 1 and 2 series of satellites, where we had VHRR as one of the major instrument providing weather related information over Indian continent throughout the day and night by monitoring the cloud movements. The second generation INSAT 2 series was designed and developed indigenously by ISRO, while the INSAT 1 series was of course subcontracted to Ford Aerospace USA. Thereafter, starting with INSAT 2 and now with INSAT 3 series of satellites, we had today most of the weather satellites from geo platform use 3-axis stabilized systems. Around 2 decades back, ISRO started working on this INSAT 3 series of satellite with a proposal from Indian Meteorological Department. In order to bridge the gap between INSAT 2 and INSAT 3 series, the first dedicated meteorological satellite named as Kalpana 1, named after Kalpana Chawla, was also launched. Kalpana 1 became the first satellite that provided images at 30-minute interval compared to the earlier 3-hourly images. So, Kalpana 1 was a inflection point as far as our meteorological forecasts are concerned, and these were followed up by the development of INSAT 3D as well as 3D R missions followed by the launch of INSAT 3DS satellites recently on 17th February 2024. So, these 3 satellites together along with its constituent imager as well as sounder instruments are providing plethora of information which are readily available for usage by Ministry of Earth Sciences and the other associated institutions of Ministry of Earth Sciences. So, we have also provided operational satellites primarily for ocean applications apart from these meteorological satellites using based on INSAT 3D series. So, the OceanSat series of satellites have several indigenous instruments starting with pencil beam spectrometer as well as ocean color monitor, which are the major instruments on board the OceanSat 2 and OceanSat 3 series of satellites. It was earlier preceded by OceanSat 1 series, which contained a ocean color monitor as well as a multi-channel multi-frequency microwave radiometer. OceanSat 3 series was almost a repeat of OceanSat 2 satellite with the addition of sea surface temperature monitor. Unfortunately, the SSTM didn't work for long, but we are going to launch another OceanSat 3A satellite very soon, which will again contain the similar combination of OCM3 spectrometer as well as sea surface temperature monitor. And I am sure that these 2 satellites together will be utilized for various oceanographic applications which we have planned. On the ocean application side, SAC ISRO has worked very closely with INCOIS, starting with potential fishing zone related identification to satellite data assimilation aspects. At SAC Space Application Center Ahmedabad, we have the end-to-end capability of instrument design, development, data processing and biogeophysical parameter retrieval. So, that makes SAC a unique center which feeds into the various application activities being pursued by INCOIS as well as other allied institutions of Ministry of Earth Sciences. At present, we are working on the recent proposal from Ministry of Earth Sciences, on which we had been working since last couple of years for defining the 4th generation INSAT series, which will be state of the art and competing with the state of the art instrumentations from other spacefaring nations. It will provide for enhanced capability for nowcasting of extreme events, numerical weather prediction and environmental monitoring, as well as oceanic and terrestrial application with very high spatio-temporal resolution to match the present state of the art capabilities available with many other advanced countries. It will also give lightning related information. So, ISRO is also putting a parallel effort in developing other advanced instruments and demonstrating their capabilities through opportunity based microsat type of satellite missions. So, which are launched on board our new small satellite launch vehicle. One such payload, millimeter wave humidity sounder, has already been launched and has been giving excellent data since last almost 1 year, and which has been much appreciated by user agencies like NCMRWF, IMD and other international agencies. So, now we are planning a full fledged mission involving temperature as well as humidity sounder in due course. Similarly, we are about to launch our microsat 2C satellite, which will contain another unique payload known as GNSS reflectometry, along with a very high resolution electro-optical IR payload with 8-meter resolution from TIR and MIR channels, which is all set to be launched this month. So, these opportunity missions will provide a precursor inputs for defining a full-fledged missions in due course. ISRO is also collaborating with various other international agencies like NASA, CNES, JAXA, European Space Agency, etc., to develop various advanced instrumentations. Megatropics and Saral Altica are flag bearers of our earlier attempts at international collaboration, and of course, everybody is eagerly looking forward to the launch of NASA ISRO Synthetic Aperture Radar Observatory, which is due for launch in next couple of months. And similarly, we are already started working on a collaborative mission with CNES France known as Trishna, which is going to be another important milestone in our collaborative efforts with France. With the new space policy 2023, we would like to work together with Ministry of Earth Sciences to enhance the Earth observing capability as well as other meteorological related observation capability using advanced active and passive microwave and optical, electro-optical satellite instrumentation, both from GEO as well as LEO platforms. This is likely to boost the future ambitious program which are been planned by Ministry of Earth Science for enhancing the weather and ocean prediction capabilities in our country. And once again, thank you for this opportunity. I extend my best wishes to INCOIS and Ministry of Earth Science for the success of this workshop organized today in collaboration with NRSC Hyderabad to celebrate this first National Space Day. And I am sure that we will be working together, collaborating on various important missions for the benefit of the common man and society in our country. Thank you.
Thank you, sir, for your opening remarks. Now I would like to invite Dr. Harsh Gupta, former Secretary, Department of Ocean Development, to deliver his opening remarks.
A very good morning to all of you, and I'm delighted to be here. And it's such a pleasure to see that the hard work of Department of Space finally has proving results for the whole country, and we are all very proud to be associated with the National Space Day, and my compliments and best wishes to all involved. Now, I'll just try to talk a little bit about INCOIS because I have known it growing. And when I entered today in INCOIS, I felt so fresh and good with the greenery all around. And this reminds me back of a Narendranath, who was first person who started working in INCOIS. And that time it was NRSA, not NRSC. And INCOIS was located there. Then of course we moved. And after that we had Radhakrishnan as the director, a wonderful person, and all this construction, etc., took place under his directorship. Also, he did so well, he ended up being the Secretary of Department of Space, and he was joined by equally talented person, Shailesh Nayak, who did wonders here. And now he was again elevated to be the Secretary of Ministry of Earth Sciences. And then after that, Dr. Shinoy was here for a long time, and internationally, one of the best known scientists from our country has been Dr. Shinoy. I've attended many IUGG meetings, I've been president there, and I always found him there at the top. And after that, we have got Srinivas Kumar. Mostly directors of India run for UNESCO jobs. He is the only example I know of who had a P5 job in UNESCO and came back to India. So compliments to him. We also have Ravi Chandran sitting here. Ravi Chandran also spent some 8 or 9 years, 12 years here. And then he's a remarkable person. I think he's the only person who has worked on every autonomous institution of Ministry of Earth Sciences. And now we are fortunate to have him as heading the department, Ministry of Earth Sciences. So this synergy between Ministry of Earth Sciences and Space has been very long born, and it has borne very fruitful results, and I think it will continue. I will just remember one incident connecting with Dr. Sarabhai. I'm talking of 1967. At the National Geophysical Institute, I was trying to set up the Seismological Observatory, the worldwide standard seismograph network observatory, with no help from US or anyone. We are doing it independently, indigenously. And that time, I don't know how many of you have been to NGRI, but it's a 150-acre campus. And there was not much, only there was a magnetic observatory in 1967, and we were setting up the seismological observatory. Dr. Vikram Sarabhai was on a visit to Hyderabad. His time was very precious, and every director wanted him to visit his or her laboratory. And he gave half an hour's time to Dr. Harinayan, the then director of NGRI. And Dr. Nayan spent some time with him, then he brought him to the site, and Vikram Sarabhai came to see the seismological observatory. and he must have spent 10 minutes with me. I explained everything that we are doing, why are you doing it, what is so special about it, etc., etc. That was the first time and the only time I met Dr. Vikram Samharai. After that, in 1967, on 10th of December, which is 11th of December in Indian Standard Time, we had the Koina earthquake, which destroyed a lot of imaginations about the stable continent region, etc., etc. And there were more than 200 deaths. And after that, a meeting was organized in Bhabha Atomic Research Center to look into Koina earthquake, why did it happen, was it triggered, induced, etc., etc. Most engineers would not believe that it has anything to do with the reservoir. Dr. Harinan went there, and he asked me to come with him. So naturally, I went with him. I was just, in 1967, I was just 25 years of age. And in that big hall, there must be 200 plus people. Dr. Vikram Sarabhai was chairing it. On the front row, there was Dr. Harinan, Balakrishna, all those top people. And the discussion went on. I was sitting in 10th or 12th row. Suddenly, Vikram Sarabhai said, Harsh, do you have opinion to express? So this was Vikram Sarabhai, with whom I spent only 10 minutes. And he could locate me. He remembered my name, and he knew that I had something to do with seismology. So such people, a department which is headed by such people, and later on many illustrious people have done it. So I'm very proud to be associated with this function, and I wish you all the best. Thank you very much.
Thank you, sir. Thank you for sharing your experiences with INCOIS, with NGRI, with ISRO. It's my distinct honor to invite Padma Shri Dr. Sailesh Naik, former Secretary, Ministry of Earth Sciences, currently Director of National Institute of Advanced Studies, to deliver the keynote address.
Thank you very much, and I'm extremely happy to be here in INCOIS, where I spent a couple of years, not much, but it was one of the most pleasing experience which I had. And my greetings to all of you on the first National Space Day. The Earth science, or Earth system science, and the space has a very symbiotic relationship. When the 1960, when the satellite era started, of course Sputnik was launched, but the TIROS was the first meteorological satellite. And we started looking at the Earth as a whole. The several pictures of that provided that there are many processes which are quite global. And we also understood that the different components, atmosphere, ocean, the cryosphere, biosphere, geosphere, there is exchange of mass and energy between them. And within the each is very critical for us to understand the climate, weather, hazards, and many other processes. And this led to a new field in 90s, the word came, as the Earth system science. We looked Earth as a whole system. And in this process, the Department of ISRO and in then Department of Ocean Development in 92 came up with a project on ocean information services. And that was the actual idea of INCOIS came. But before that, India Meteorological Department, many of you may not know, but started using satellite data in 1965. The 60, the TIROS data, and mainly used to understand the cloud movement and monsoon. So now the Earth Department, Ministry of Earth Science and the ISRO has a very close relationship since beginning. And that is why now the way we define the Earth system science has, of course, the science part of the Earth, but also includes the space science, technology, and engineering. And this information has to be used for the society. So we also include the social science and economics, and the most important, the human behavior or thought process, or the what we call as a cognition, is also part of the Earth system science. And I'm very happy now that under the leadership of Dr. Ravichandran, the many aspects of the social science is now being included as a part of the projects. So the idea of a Earth system science is very critical. And there are many issues which keep on happening on the different fields. I'm not going into details, many of you know. But today, in the all numerical weather prediction models, the assimilation of satellite data is one of the most important. Dr. Prasad is here, Dr. Mahapatra is here, and they know. In my rough estimate, you can correct me if I am wrong, almost 90 to 95% data which is used in numerical is all from satellite. Not necessarily all Indian satellite, but there are a lot of global missions, so all that. So this is another important thing. There is another area which is very important is it provides you the information about the various interaction, let's say outgoing long wave radiation and the convecting, the precipitation, and of course these people know much better. But there are several things which is now we are able to understand much better. One of the classic case of transferring the latent heat when there is a heavy rainfall in northwest India, that heat transfers right up to Canadian Arctic. And this is done through INSAT by Dr. Krishnamurthy. So there are several such examples which we understood how the global processes could be studied from the satellite. Now, some of the importance of this, the agrometeorological service is one, and now that is extremely good example how farmers can adapt to the climate change. Though it was not started that kept in mind, but now we realize that it is one of the best way to adapt to the climate change. Now, what we need to do in future? What we realize is that in the forecast, the wind plays more important role than the property of mass, humidity or temperature. Our focus is more on the property of mass, but not on the energy. And we need a wind profiler to improve our forecast in the tropical region. We have been discussing for last 10 years. I understand SAC started some activity, but it's not progressed. I think this is an area which we have to focus for the future. Cyclone, of course, we know, Dr. Mahapatra is here, is one of the classic example of how the satellite data improved along with the models. But what we now further need to do is that how do we get the entire hydrodynamic structure, maybe hyperspectral or any other ways. This is an area which we need to understand for further improvement, because that will tell us about the associated intensity and rainfall, which is not very precisely done as it should have been. There are extremely good examples how the INSAT is used for thunderstorms, western disturbance, and many others. Now, these all have been used for saving lives, and that is, I think, one of the major example what space can do. Similar we have in the examples in geosphere. The generation of DEM is one of the basic input for us for most of the applications in geoscience, including the hazards. The important thing, what we need is now, the Dr. Nilesh mentioned about NISAR, but we need this data to measure strain everywhere, not only at the plate boundaries, what we are doing with GPS. Because the minor changes which are happening in different places is equally important to understand where the hazard is likely to happen. It could be landslide, it could be earthquake, it could be volcano, or anything. We need to understand the minor changes which are happening on the Earth's surface. And I think the NISAR would be one very important aspect in this. We have not been using much GRACE and magnetic data. We started magnetic in '84, but later on not much work has been done. I think we need to focus on this also. The gravity, along with Dr. Tiwari is here, and he has shown very well that how the changes in the groundwater can take place. And this, we don't know, like in northwest India, the amount of water has been taken out, which created a major issue, but where this water has gone, we don't know. It has gone somewhere, whether it is in atmosphere or whether it has gone to ocean. So huge mass has shifted, but we don't know. I think that satellite can give us a quite good idea. We also need a good geodetic network along with our navigation satellites. Survey of India has already done this, but we need this information more in areas which are hazardous like Himalaya, Western Ghats. That density is very poor. I think we need to further improve upon this. There are many examples on the hydrology which we have done extremely well. Most of the operational work on groundwater, surface, wetland, everything done through satellite nowadays. Ocean, of course, all my previous speaker has said, so I'm not going to say much on this. But the last topic which I've been told that how this whole thing get translated into a blue economy. Now, why it is so important? As I told you, the Earth system science has to look about the economy. We know that there is about total economy, the estimate vary between 3 to 6 US trillion dollars, and our contribution is about 4%, which is very less. So India, the Economic Advisory Council to Prime Minister has already provided a framework that how we can use this information to further improve upon the economics. Now, where the remote sensing or the space comes into this. One, of course, the potential fishing zone. The amount of benefit which comes is, one estimate is around 17,000 rupees per trip. This was done by National Council of Applied Economic Research. The sea state, also the huge benefit to the various fields, navigation and all that. But what we need now is how this information can be used for deep water fisheries. I understand the tuna, it is already being done, but that is very small portion. We need to build this deep ocean fishery, and CMLRE has done extremely good work, how we can translate this into an economic benefit which we have to see. We also need to see now that we should be able to sustain this. So we should be able to fish within the sustainable limits. And that is why we need a species-wise stock assessment, like what we do for wheat and rice and paddy. We should be able to forecast what is the stock likely to be available in this season for sardine or a mackerel or any other commercial species. And this is possible because there is a physical biological relationship which could be picked up in satellite very well. If you pick up any satellite and see SST and the chlorophyll, you will find very close relationship. But how this can be converted into a model, which is a major issue, but I think I'm sure that it could be done. Other is the economic value of our coastal ecosystem. A lot of work, I think Raman Murthy is not here, but he has started this work, is there, started his work to find out the economic value of this. And this is very important for us, not one, and the total carbon stock which is available, which is all done through satellites. The coral is another area which is very important, and the information first time came about corals was using the satellite data. When you have a large amount of activity on the coast, you need a management plan. And today, the entire management plan is made based on the satellite data. And this is probably the only case where Government of India has mandated to use satellite data to prepare the coastal zone management plan. And entire country's coastline management plan today is made through a satellite, and the whole center has been set up for doing this in Chennai. Similarly, the other aspects of the coast, like shoreline changes, the water quality, is all being done now through satellite in National Center for Coastal Research. When you have this kind of activity, you need a response mechanism. We have extremely good, Dr. Srinivas mentioned about tsunami, cyclone, all we have an extremely good warning system. But how do you find out whether you want to set up an industry? What is the vulnerability of this coast? And the INCOIS has done an atlas for the entire country's coastline, where this has been used, the satellite data for shoreline and the topography has been done. Now, in concluding, I would say two things. One, there is no doubt that satellite data is the mainstay in Earth system science. But we do not have a plan that how this would be continuing. Dr. Nilesh mentioned that INSAT and OceanSat. I think there is a need to define what is needed each state, like INSAT or OceanSat, the scatterometer, altimeter, also the ResourceSat, Cartosat, navigations. What is that requirement? At what frequency is required? Like scatterometer, Prasad needs scatterometer data every 6 hours. If you give every 48 hours, he may use it, but it's not very useful. So what is the requirement of the Earth system science or the modeling? That should be done through satellite. And I'm not saying it should be only Indian satellite. We can collaborate with US or Europe. But this should be ensured that if I'm going to invest in the assimilation, I need 6-hourly data. The Saphir was another example. Extremely good results came out when you use the Saphir data. But there is no continuity plan. So I think there is a close interaction required, and I would request Secretary MOES and of course headquarter Dr. Thomas is also here, to set up a mechanism by which this aspects is continuously reviewed and planned. Why it is important that if we say that next 10 years, I'm going to need 40 satellites, industry will come forward. Industry won't come forward unless and until they know that their investment is going to be there for next 5 to 10 years, they are going to get a market. And I think this is very important. The second thing which I would say is that the knowledge which we have on the Earth system, which includes the satellite data, this information we should be able to integrate along with the kind of policy change or the governance structure which you need also has to be integrated. Many times this is not happening. Like even if we know many times now that the Prakash was mentioning about the landslide vulnerable zones and many such information. Now, what is the governance structure need to this information? We do have information, but it is not able to use it. So we need to understand this aspect, that I have this information. To utilize this information, what kind of a policy change or a governance structure you need. And at the same time, you also need understanding about the human system. We have seen this, Dr. Mahapatra will agree, on East Coast, when there is a warning, people evacuate easily. But same is not true on the Western coast. Srinivas did one mock drill and found that in East Coast, most people act within 10 minutes, while on West Coast, it is 90 minutes. I think those aspects now, it's time that we take into account. Then I think both our knowledge gained from satellite, from the Earth system, will be really useful to the humanity. Thank you very much for this opportunity.
Thank you, sir, for your enlightening and inspiring keynote address. It's my pleasure now to invite Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to deliver his inaugural address.
Dr. Gupta, Dr. Shailesh Naik, Dr. Prakash Chavan, Dr. Srinivas Kumar, Dr. Mahapatra, Dr. Prakash, and Dr. O.P. Sharma, and Dr. V.M. Tiwari, and Dr. Tamban Melot, and my dear friends from various ministries, especially Ministry of Earth Sciences, and I am seeing many of equally well-represented space scientists from NRSA, and my colleagues and friends from INCOIS and various other organizations. Very good morning to all of you. First and foremost, greetings to all of you on this special day on National Space Day. And it is a very important day, as already Prakash mentioned about the importance of this day. And as you all know that the Earth is nucleated from the space, of course from the solar system and space. Similarly, this INCOIS also is nucleated from space institution in NRSA. It has nucleated and it has grown over the periods. Of course, I was thinking of many of the points which I want to narrate, but unfortunately, so many stalwarts, especially from space, right from the, from Srinivas, Prakash, and maybe Nilesh Desai, and also finally with Dr. Shailesh Naik, they have dismantled all my points what I have written. This is a sometime problem. I think if had I know all these people are there, then I would have excused for not talking. Instead of inaugural address, I should have talked to vote of thanks. Okay. Having said that, of course, you all know that the Indian space program and of course the Department of Ocean Development started together in 1980s. Of course, both departments started. I always feel that the space has gone far away, and still ocean development has not gone that much deep. People ask why. I always tell that space is the air density is so less, So they have gone faster, whereas our density is little, fluid is little harder. Not only fluid, that also the solid rock is very difficult. So we are very slow in that process, but we will catch up definitely. I think space has contributed to the Earth system science. Basically, the Indian satellite mission to contribution to the Earth system is enormous in terms of science as well as services. I think it started in, of course, from the Indian space mission started in our field, especially in 1990, started with the Marxist program, wherein we started with how the space technology or space remote sensing technology used for marine application, how we can retrieve information, thereby we can contribute to these services. Because always right from the beginning, the space mission that means aimed for to provide the services to the society. And later it started in 1997, around that time it started SATCORE, that is a satellite application for ocean application, especially from the Space Application Center, and also from INCAIS. It is jointly, it is coordinated various applications, how we can derive various ocean information from the satellites. It has been started that program. That program has provided many of the services. Maybe you take it potential fishing zone or ocean services, or many of the very harmful algal bloom and many other applications it has been provided, even including coastal erosion and coral watch and other things. One of the flagship program is, of course, the potential fishing zone. Though it started in that year in 1990s and maybe 2001, it started from INCAIS. That is the program. PFZ is the initiation from the INCAIS. One of the service-oriented program it is started. Of course, INCAIS started with majorly with the two program, one for local, one for global. I always feel proud of that. Local means you get the satellite services and other things for the local community, and for global means like Argo and state-of-the-art observations for us global community to contribute. Thereby we get everybody benefit. So that's the way it started, and both has gone in long way. Of course, when you talk about that one is for remote sensing and other one for in situ. These two are very complementary in nature. Of course, always we can think about space is providing. It is one kind of observations. Of course, nowadays students and many of the people are space oriented. I mean space oriented means they know more information on the surface, but they don't have in depth. Whereas I feel always that Argo or Radio Sunday, it is in-depth information, but not spatially well informed. So that is why we need to have a complementary nature. That is why when space scientists and maybe like earth scientists to work together, both the ground truth observations or space observation, they have to contribute together for the benefit of the society. And then later on, I think in 2011 or so, we started with the, of course, 2007, we started with the Kalpana and the INSAT series started for meteorological community for providing, I think that is the time we started quantum leap for in terms of weather forecasting as well as especially cyclone monitoring, especially how the ice forms, so that the initial conditions, how we will be able to monitor. It has been better depicted by the satellites, so thereby we are able to give better forecast. And apart from that space remote sensing, the important contribution to the earth scientist is our space community is basically establishing the ground stations at all our MOS institutions. Either it is IMD to receive INSAT data, and at INCAIS to receive ocean data, and at NCPOR to have a better communication in both Maitri station and later on in Bharati. So we have established ground station which has been established by the space community, and then we are able to receive the data, and it is very important contribution. You know that until that time, I think Maitri and Bharati, the communication is very poor. They do communication in few minutes. After establishing this Maitri station, especially in the communication, they are able to have better connectivity with the mainland. And of course, they recently, then maybe last few years, they have started with the ground station data reception from the Earth observation satellites, especially X-band and S and X-band satellites from Bharati, so that we get more passes to download. So these are the past, whatever happened. But of course, the present status in the present time scale, maybe the maybe near past. So we have done maybe 3DR in INSAT 3DR, and now they have launched 3DS. So we are able to get improved day by day the quantum of accuracy of the satellite information, as well as the passes and many other things we have improved in these satellites. And then OceanSat 3 launch for the color and winds, and also we have a very good information we are able to get from the sea ice advisory especially in the Antarctic waters. When our ship goes, people try to give the sea ice advisory. It was very useful so that we are able to navigate in the coastal Antarctic waters. And apart from that, because that technology they have evolved, they are able to provide many other information, especially what is called Doppler weather radar. They are able to establish right from the SAR. Then later on, they have deployed many places, Serapunji and other places, and that was very handy. So that now in the industry, many of the ecosystem, they are able to start what is called Doppler weather radar in India, so that now we are able to make we are able to get the Doppler weather radar from the Indian industry, so that we can make use of that information. Not only that Doppler weather radar, but also radio sonde and other things. So it is a side effect of many of the technology, space technology has contributed to the Earth scientists. Of course, now it is going on phased array. It is going on in phased array sensors also going on. And also there are communications. In the ocean, especially the small, the battery and other things are very small in availability of the battery capacity and other things. So they are able to make what is called deploy DRT, that is the data, what is called transponder, very small transponder, so that with the minimum battery, we are able to transmit that to the satellite and we get the information. That is very important contributions in the communication aspect, especially in the ocean, as well as some of the other areas. And that contribution, so we have sandwiched more and more closeness with the space scientists as well as the Earth scientists, and we are able to work together in many other aspects. That has come forward with it directly. When we started with the deep ocean mission, many of the things we are looking at, it is not available, so they are able to provide the underwater navigator, and now they are able to develop and they are able to provide, and that will go into the deep ocean mission of this Samudrayan. And also the titanium sphere, it is presently being developed and welded at Space Center, so that it will be very useful for the deep ocean mission. So these are the various things which is going on between space and Earth scientists. Of course, what we want is, that is more important, of course, in futuristic, of course, many of the satellite sensors, and it has been highlighted. I will not repeat, but mostly, of course, we are expecting OceanSat 3A, and I think it will be having new sensors, maybe the maths, especially microwave sounder and scatterometer, we are looking at it. INSAT 4th generation has been talked about. And as I feel that, of course, the Sapphire kind of things, it is very need of the hour. If we see that the primary things in the atmosphere, we want to go for better predictions, always we look at the, of course, as Dr. Nayak Sahab told, we required not only tracer, but also the dynamics. The traces like temperature and humidity, yes, that is need, not only at the surface in the entire profile, but also we need the wind profile, so that we know the dynamics where it is going, so that the energy where it is transported, that is very important. So that is why entire space, we require temperature, humidity, and wind at different time scale. At least we need to resolve the diurnal. So these are the main requirement in the atmosphere. Similarly, in the ocean also, temperature, instead of humidity, it is salinity, and instead of winds, it is a currents. These are the prime variables, and how it is interacting or how it is talking with the atmosphere and ocean, that is more important. So that if you are able to monitor, and then we are able to have a better predictability, because this always meteorology or ocean predictability is mainly depends on the initial value problem. If you have the better initial condition from various observations, our error will be less. Otherwise, the initial condition will, if it is more error, the error will grow. So that is a basic fundamental. That is why these observations are very important. Mere in situ data, it is very difficult to have what is called, everywhere you get to better initial conditions. As rightly pointed out, more than 90% of the data, comes from the satellites. And also the impact, if you see that, it is also comes from there. Because of course, ground station measurements very less. Of course, now we want to have more and more utility of GPS radio occultation methods, as well as the techniques, as well as the informations. And also we need, very basic need is, we need like a SST type of observation from the microwave with the fine resolutions. I think that is in the tropical regions, the SST in fine scale, not by coarse resolution like a 25 kilometer. So it is very, very fine scale, even in the microwave things, not by NOAA, AVHR or anything. It is basically in the microwave things, if it is able to get the SST. The SST and wind, these are the two fundamental, both in ocean atmosphere, in terms of Earth system. So that is a major things. How accurate, how repeativity we get it, that much our forecast will improve. That's the main crux of this one. And also we have to go for, as many pointed about, nicer. I think it's going to come, it will be nice. We have to look at various aspects, not only from meteorology as well as the ocean, but also in the solid earth. We will be making use of solid earth as well as solid ice, as well as the other tectonic and other things. We will be making use of it. And as always the dream, this recent ALOS, some European satellite has been able to demonstrate the wind profiles from the satellites. That has demonstrated the value of the forecasting. I think it will be ideal if you plan to go for wind profilers, so that it will be useful for the better forecasting and other things. Of course, there are more and more data collection platforms are required. So I always dream that tropical country, we should have like a trim set of trim LIS and lightning sensors, because the lightning is going to be increasing day by day, year by year. It is going to, the frequency is going to be increased. So as of now, the more number of deaths in the natural calamities is lightning. So I think we need to develop some lightning imaging sensors, and such type of things we need to monitor, and we have to continuously monitor. And also we need to have some of the LIDARs, especially for atmospheric properties and cloud height and aerosol informations. We need to make it. And some, of course, in Delhi, like people, they always required spectrometers to identify gases and its concentrations for making better air pollution monitoring as well as the forecasting. And when you go to polar science, if you talk about, we require the sea ice thickness information, the sea ice extent information, and of course ice surface temperature. That's a new things which is very important. What is the surface temperature at the ice surface? And also what is the more important thing is, especially in the Himalaya, we know the aerial extent of the glaciers, but we also need to thickness of the glaciers so that we can quantify the volume of the water available, because these Himalayan glaciers depend on 2 billion people, how long it will go. So we need to, we don't know how much is in tower, we don't have in water tank how many water is there. Unless we don't know how do we use it properly, sustainably utilizing that, we need to know that information. So all these things are very important. So space has to contribute a lot in the coming decades and years also. Of course, in the earth science, we are coming with, of course, deep ocean mission has come. This is a pilot project of blue economy. Now the major blue economy components will come up very soon. And also very soon, again, another mission, because we are going for all 3 missions together. Now in the coming, maybe this year it will be realized. One is for atmosphere, we are going for MOSAM mission, and for ocean, blue economy, and for solid earth, we are going for polar mission. So all the 3 missions will be reality in this 1 year time frame, and during that time frame, we will be heavily dependent on the space contribution, especially various observation systems. Of course, I am looking forward this workshop. I think we can discuss what is our important recommendation to space, what we need. I think, of course, first and foremost, we thank the community for providing various informations. At the same time, now we want to go for further going beyond. For that, when we are looking at the India in 2047 vision, for that we need to establish the infrastructure before 2030. For that, what is our plan? Maybe what type of satellite we have to have and what information we need to get. So all these things we can discuss, and at the end of today, it will be good if we get some recommendations. This is what we need from Earth Science community. It will be very good, and that will be, we can communicate on August 23rd when National Space Day is celebrated at New Delhi. With this, thank you all coming, and especially I thank especially the industries. I think your input is required more and more. I think we will come out with a special edition, especially in the small satellites, what are the things required, especially I was talking about wind profiler, why we cannot go for nano satellites and micro satellites, so that we can have more and more informations in that, because now we have to work with the industries as well as the academia and national institutions. We have to work together to get the maximum benefit. With this, I thank you one and all, and thank you for coming, and once again, greetings on this National Space Day. Thank you very much.
Thank you, sir. Thank you for briefing the importance of satellite data in the Earth system science. Thank you for the insightful inaugural address. Now, I would like to invite our Director Inquiries to felicitate our distinguished guests on the dais. Thank you, sir. We have an exciting technical session with distinguished speakers lined up after a short break of high tea. Please join for refreshments arranged in the foyer, and kindly join back in 15 minutes. I request all industrial partners to stay back for 2 minutes. Only industrial partners. 2 minutes, sir. After 2 minutes. 2 minutes.
Good morning, everybody. Welcome to this technical session. I would like to invite Dr. Prakash Chauhan and Sri Pattabhi Ramarao, Group Director Inquise, to chair this session.
Okay, good afternoon, friends, and welcome back to these technical sessions. And since we are running already late, and we have 5 very interesting, talks which are lined up, I will request the presenters to, even though 10 minutes have been given, you may like to finish your presentation in 8 minutes, and 2 minutes we can keep for, some small interactions, because that's very important. So now all of you are veterans of, making presentations. So I will leave it to your ability to finish your presentation in this short time. I would like to invite Dr. J.V. Thomas. He is, Director of Earth Observation and Disaster Program Office at ISRO headquarters. And he's going to enlighten us about the current and future satellite missions for Earth system applications. So Thomas, please, we need your cooperation and help so that we can finish this session fast.
Former secretaries and the current secretary of the ministry, directors of several organizations, several institutes of Ministry of Earth Sciences as well as ISRO, and all my colleagues from ISRO, INCOIS, students, media, very good afternoon to you all. I'll try not to upset all of you. I'll try to complete as early as possible. So the Indian Earth Observation Program, we have got different dimensions are there. One is space segment, a constellation of satellites in land and water cartography, ocean and weather. Then the corresponding ground segment is there for receiving this data and processing. And various space applications for the national imperatives and socio-economic developments we have developed. And also during this process in the past 60 years or so, we have developed close linkages with the ministries, departments, states, and industry and academia. So the remote sensing capabilities, as we say, what is there today? Today we have got ResourceSat series are there. And in ResourceSat series, 2 satellites are still working. It is providing a 3-tier imaging of 56 meter, 23 meter, and 5.8 meter with the varying revisit capability along with the varying with the resolution of the satellite, resolution of the payload. And also we have got a microwave satellite, RESAT 1A, is in C-band SAR. It has got a 3 to 50 meter resolution and 17 to 24 days repetitivity. In high resolution area, we have got Cartosat series. 2 of them are in the civil domain. It gives 60 centimeter panchromatic data and 1.5 meter multispectral. And Cartosat 3 is providing 28 centimeter panchromatic data and 1 meter multispectral data. In ocean arena, we have got OceanSat 3, which 1.5 years back we have launched. It has got an ocean color monitor with 13 bands and also a KU band scatterometer that is for the wind vectors. And we also had a sea surface temperature monitor, but unfortunately, after 3 or 4 days, it has stopped working. This satellite is being commissioned now. It gives ocean color, sea surface wind vector, And also we have got a Saral satellite, which is an KU band altimeter, which has been launched in 2013 for a lifetime of 5 years. But even after 11 years, it is giving very useful data. We have recently taken a decision to continue this mission till 2025 December. We will be continuing this mission, provided there is no more deterioration in the payloads. This gives an ocean sea surface height information we are getting, and that data is still being utilized by NCMRWF as well as Space Application Center. It is being used. In the weather domain, we have got we had INSAT 3D and its repeat 3DR. This was giving 2 satellites together. It was giving 6-channel imager. That is around 2 satellites together, 48 images per day it was giving, and a 19-channel sounder for atmospheric profiles it was giving. Recently, the 3D has been replaced by INSAT 3DS. Now, the INSAT 3DR and 3DS, the S denotes a ground spare. So 3DR and 3DS together, it is working, and it is providing the same continuity services. And INSAT 3D is being shifted to 129 degree. Out of that imager and sounder, only imager is working in 3D. But we want to use it we want to use INSAT 3D also. We will be moving it to 129 degree, and a different position we will be operating INSAT 3D also. And we also have got the capacity for the aerial and UAV capability is there. And also for validating, we are operating several terrestrial in situ observations such as sondes, Doppler weather radars, automatic weather stations, and ocean buoys we are operating. So only one satellite once again I'm coming specifically, which is a millimeter wave humidity sounder, MHS, which has been launched recently on an experimental mission. This has been, earlier Shailesh Naik sab was telling about the Saphir, and also Secretary also was telling about the Saphir humidity profiles. That continuity we were missing after the megatropic satellites, and for that we have indigenously developed a humidity sounder, and it has been launched into the orbit. And we are happy to say it is giving a very good results, and it has been validated by both Ministry of Earth Science, NCMRWF professor is here, and he has also validated that data, and also Space Application Center and all our user community has validated, and it is found that a very good data is being provided. Humidity sounding is being carried out with these satellites. And during this time, it is after 2020, you are aware that reform has been taking place in the space sector. And now with the new reforms and the space policy, the easy access of remote sensing data is ensured. And in the private industry is enabled to participate in end-to-end activities in space sector, from the data generation, operating a satellite, and also disseminating the data. And also geospatial policy 2022 also is ensuring the availability and public funded geospatial data to all the thing. For that, we have already, with whatever the required, the policy, everything is in place. The PC SAMS mechanism we have formed again in 2021. This is in the same format of National Natural Resource Management System, which was active from the 1983 onwards. NNRMS was acting, and the same continuity we have formed PC SAMS with various thematic committees, and the thematic committees recommending the missions to the PCSAM Planning Committee, Space Application Management System, and all the guidance and approvals are being obtained from PCSAMs. The EODO Data Dissemination Guidelines of 2023, which ensures data of 5-meter resolution and coarser, will be available to all free of cost. And also the data finer than 5-meter resolution also will be available to all. but on free basis to all the government agencies and all others with a very fair pricing it will be available. And also the thematic data derived out of this above 5 meter resolution data also will be available to all free basis. For that we have started a Punidhi portal at NRC is being managed. All this free data will be can be downloaded from the Punidhi portal. In the upcoming satellites, we have got a continuity satellites are there, and also few of the international collaboration missions are there. RESAT 1B, I have told RESAT 1A in C-band is operating. RESAT 1B is a continuity satellite on the same C-band, similar specification. And also OceanSat 3 is, I have told, and OceanSat 3A we are planning in the next year. In that, we will have again ocean color monitor, scatterometer, and also sea surface temperature monitor will be there. And also because some opportunity is allowing, we are also trying to include a temperature and humidity sounder. I mean, MHS I have told, in that only humidity sounder is there. And here temperature and humidity sounder also will be included in the OceanSat 3A satellite. And NISAR, you have heard about the NISAR, NASA ISRO synthetic aperture radar. It will have L and S bands. L band is being produced by, developed by JPL, and S band is developed by ISRO. This will be launched in the beginning of the next year. We have plans for a high resolution satellite. 3 satellites, initially it was planned 1 meter resolution. Now since the 1 meter resolution from the user requirement, higher resolution is required. So we are trying to improve it to around 45 to 50 centimeter resolution. We are planning to improve this satellite. And 3 of this HR satellite will be launched in the same launch vehicle, and that is also planned. And the ResourceSat, I have told you about the 2 satellites, and next generation ResourceSat we are planning. It will give 10 meter and 20 meter data with a wide swath it will be available. And also we are planning for a high resolution stereo satellite. Earlier, our Cartosat 1 was there, which is given 2.5 meter stereo data. And here it will be ResourceSat 2S series will give 1.25 meter resolution. And high resolution TAR and visible near infrared is a collaboration between ISRO and CNES, which will give around higher 60 meter resolution of temperature imaging it will be providing. That will be around 2027 it will be launched. And also the final one, G20 satellite is announced last year after the G20 meeting. It has been announced that India will provide a bus, and all the G20 countries can provide payloads in the climate change and environmental related payloads can be provided. That will be accommodated in a bus by ISRO, and it will be launched by ISRO. This also discussions with all the G20 countries are be continuing. And I have included individual one slide for all these satellites, but I am not getting into the details because of the time limit. And maybe somebody can go through, if anybody get this presentation, it will be useful to them. So I am keeping all these details in this presentation here. And today also we have heard about the further missions. We have heard so many requirements inside future generation. A committee headed by none other than Director General IMD, DGM IMD has recommended an advanced imager, lightning imager, and hyperspectral infrared sounder as the priority instruments in that INSAT 4th generation, and also several other visible near infrared, multispectral, hyperspectral imager, space weather monitoring instruments, etc. As the provides, if opportunity provides, that also can be included like that. A report already has been submitted, and ISRO is working out to generate a project report for that thing. Then we have also heard about the scatterometer constellation, which is required for the IMD and NCMRWF. altimeter, Saral, I told it's already completed 11 years or 12 years, and now it is altimeter we need to continue. Microwave radiometers, earlier we had microwave radiometers that need to be continued. Temperature and humidity profiles from LEO. The wind profiler, it has heard, and atmospheric chemistry instrument, we don't have so far anything. And also now from today's lecture, we can add payloads for...
Dr. Thomas, yeah. So we can take discussions on this.
Yes, payloads for gravity or magnetic measurements, that and all, it has come today. With strong recommendation from the user community, this can be approached, government can be approached for realizing these satellites. So the summary of this thing is, this is currently in the interim arrangement is in operation. All these satellites, whatever we have told, I have told this earlier itself it has been approved. Now this will be forming, this will be realized. And in future, all the users have to fund for these satellites. And I'm very happy that private players are also coming up with several constellations. They are yet to prove their capability. We are looking forward to the industry to prove their capability, and it will be providing useful satellite. And InSpace is also encouraging to develop private industry in development of EO missions by offering several schemes like PPP models and all. And ISRO has formed several working groups with 30 ministries. They are working together. And we hope that these multiple efforts will find results, and we hope to have the required EO infrastructure.
Thank you very much, Dr. Thomas.
In this thing.
You have already taken 4 more minutes than the allotted time. But I think still I will encourage 1 or 2 quick comments and discussion on the current and the future plans for the Earth observation satellite Dr. Thomas has presented. Yeah, yes.
So what is the resolution of NISAR that is proposed for your crustal deformations, like you wanted to know the uplift and subsidence? You have to have some idea that S and L band is there.
Yes, sir. Sir, you can see here that spatial resolution is 6 meter in the azimuth direction for S band. And L band, it is 7 meter in azimuth. Slant range, it will vary. It will vary from, that is the resolution.
Yeah, basically, we will provide almost a 6 meter by 6 meter resolution using L band data. And the product, which you are asking about, the deformation product. So normally, per pixel deformation will not be available. You can have at least 10 to 12 meter ground resolution deformation product from these observations.
So from the line of sight monitoring, you will direct get the...
Yeah, so these are all line of sight deformations only. And then later on, there are methods available which can convert this line LOS to the actual vertical or horizontal displacements. Yeah. Yes, please.
Hello, sir. I'm Abdul from Aziz. Very curious on the high resolution satellite information. And I believe 3 you are trying on.
Okay.
On the following slide, you mentioned that you do identify there are industries which are capable of doing, but there was a clause 8 to show the capability. May I know what is the criteria which you say we can participate in?
See, I think Assista BMO itself, you have in 2023, you have launched a runner with 5 meter resolution you have launched. But we are yet to see that data and how that this data...
Okay, you can tell about HRSat. This question was about that.
HRSat is 3 satellites we have already got approved. In the same launch, it will be launched, this 3 satellites. And around it will be, we are trying to get this below 50 centimeter resolution.
Okay, thank you. Yeah, Prasad.
No, not at launch, sir. It is, we are
it
planning.
Will be in public domain, yeah. All the data will be freely available. It will be, you will be able to make use of that data. Sir, Prasad, sir.
Sir, it will be launched immediately in the beginning of the next year. It will be launched, and then after validation of the data and all, it will be.
Last question, Prasad ji.
GNSSR, the special now, so far we're not handed GNSSR, that first time we're going to take that data and compliments to ISRO and SAT for going to that one. And the data you are covering only Indian region or you are going to get
GNSSR, you can answer because this is an experimental mission which is coming up now in a.
No. So, Prasad, your question is actually it is a receiver which has been kept on the LEO satellite. It will be receiving global observations of our, whenever the Navik satellite, field of view is there. In this region, you will be able to get the reflectivity from the ocean as well as from this surface. And GPS is also there, na? Yeah. Okay.
Full capacity will not be there.
Yeah, thank you, Dr. Thomas. Only to you, already a PPP mode announcement expression of interest has come for industries to participate in the EO constellation, which is now being taken up by InSpace. So I think you can bid for that to answer to your question. Yeah, thank you. Yes. I think let us give a good round of applause to Dr. Thomas for a very comprehensive presentation. And we will move on to the next presentation, which is on space applications for meteorology by Dr. M. Apatra ji. He is a Director General at India Meteorology Department. Over to you, sir.
Thank you, Chair Prakash ji or Patavi ji, and distinguished delegates, participants, ladies and gentlemen, dear students and researchers. At the outset, while he is loading, I can continue to speak to minimize the time. So at the outset, I congratulate and express my heartiest greetings to entire space community, including ISRO and various researchers, academicians, the users, the beneficiaries who have been involved with the space technology. So when I have been asked to talk about the space application for meteorology, so I thought when students are there, people should know what is meteorology. So meteorology, if you just see the name, consists of two words, that is meteor plus logos. Meteor means anything falling from the sky is called as a meteor. Logos means discourse, the study. So meteorology is the branch of science which deals with the study of the meteors. So when you talk of meteors, there can be astronomical, there can be hydrometeorological meteors. So just to go to the ancient era, towards epics, you will find that if someone is offering water to the sun every day after the bath, you can remember, it is written that Akasat patitatrayam yathagacchati sagaram sarvadeva namaskaram kesavam pratigacchati. So it is written there that only three forms of meteors are forming from the sky. It is coming to the earth. And these three forms, if you look at the present science, the rain, hail, and snow. So these rain, hail, snow are the major hydrometeors, and these are the studied through the science of meteorology. But that was the beginning, but it has come off a long way, and now it has come to simply rain, hail, snow to entire Earth system science, which we have explained, which has been listened by us from our distinguished speakers in the inaugural session. Going a little detail, in the present era, you can find that the first book on meteorologica came up by the philosopher, that is Aristotle. In our ancient era, you can find out various literatures where meteorology has come up, which explains the role of space. When I say Akasat Patitatrayam, Akash, if you just translate it, is space. Akasat Patitatrayam Jathagacchati Sagaram, it connects the space with the meteorology. So therefore, meteorology cannot be analyzed, meteorology cannot be discussed, cannot be deliberated without the space. It has been taken up from the very beginning. And meteorology as such, we know that the science for study of weather and climate. So when you talk of the space meteorology or the space-based science and technology in India, and when we remember Dr. Vikram Sarabhai, I will just want to mention here, when the first national committee was formed for the study of space, development of space technology for the benefit of the society, the Director General of Meteorology was a distinguished member of that committee. And after that, we have listened to Shailesh Naik. It was taken up in April 1960 when TIROS was launched. The India Meteorology Department was the first beneficiary in the country to utilize the information from USA. At that time, we did not have anything, but USA offered a receiver It was put up in Kolaba Observatory of India Meteorology Department, which provided the all observations, especially the images of the Earth. And with that, we could avoid the loss of people dying due to the cyclones. If you just look at the number of people dying after 1960, it has drastically reduced and further reduced gradually. But before 1960, you cannot count the number of deaths. So that was the story, how we have come up with the application of space in meteorology. So you will see that there has been a quantum jump in economy and drastic reduction in loss of lives through meteorological observations forecast for optimum operation of weather and scientific activities. At any point or anywhere in the world, if you go now, you will find that there is application of space technology in meteorology to minimize the loss of lives and properties. No weather hazard should go undetected and unpredicted. That is the motto of India Meteorological Department. You can say the vision of India Meteorological Department. And space technology has helped towards that to minimize the loss of lives. But still there are certain challenges. For example, when you talk of the people dying to the cloudburst, when you talk of the people dying to lightning, still we have got the scope to improve our space science and to come off at the international level so that we will be really a made in India space technocrat and space technologist to minimize the loss of life to the small scale disastrous weather events, which is the cause of the death nowadays. Cyclone is not causing the death of the people nowadays. It is reduced. We have seen the zero death in Viparjaya, but people are dying about 2,500 due to lightning. And cloudburst, we have seen recently how 200 people died in Kerala, or with cloudburst or landslide, whatever it is. So it is not detected properly because the limitation of the resolution of the satellite and also the quality of the data. So we have to address that. We have been very successful to minimize all this case, to optimize the utilization, but there is still scope to improve further and go forward. Now, if you just look at the space-based observations for weather monitoring and forecasting, yes, monitoring of weather hazards is the key success, I will tell you. I have just noted key success because of the space technology in India. One is the weather hazard monitoring detections, development of the climatology, physical understanding. For example, when you talk of the El Nino and southern oscillations, when you talk of the Indian Ocean dipole, when you talk of the Maiden-Julian oscillations, when you talk of any oceanic climatology, or the hill area climatology, the space science has contributed. The space meteorology has improved day by day because of the contribution of Indian space organizations and many research and development taking place utilizing space data. Similarly, the hazard mapping. The hazard mapping has gone up a long way. NRSC has contributed a lot. We have got land surface, land use, land cover data so much that you can go for hazard mapping in the real time and also develop the climatology of land surface. Okay. Assimilation of data, everybody is told, about 90% of the data utilized in numerical representation models are based on the satellites. Of course, it's not only for Indian satellites, but it's a global satellites. There is a consortium, we've got a CGMS, cooperative group of meteorological satellites, through which all the meteorological data throughout the globe are shared and exchanged and are utilized in our numerical representation system. Prasad is here. So I will tell again, whatever data we utilize the model, that is only 5% of the total data collected through satellite. So here is the scope for our startup group, for our industries, for our students and researchers to find out how can we maximize the utilization of satellite data in weather and climate. It is not the whole data now utilized in the numerical modeling systems or in data operations. And used for nowcasting, short range forecasting, mid range forecasting, extended range forecasting, and also the climate forecasting like monsoons. And there has been proof that there is 25 to 30% improvement in forecast of the NLP models because of utilization of the satellite data. Okay, so these are the various applications. One of the most important applications is I told you that weather monitoring and climate monitoring, then weather and climate modeling, then climate services, development of climatology utilizing satellite data, then of course the disaster risk reduction, as some example I have told you about this. It may include thunderstorms, heat waves, cold waves, drought, floods, etc. And there has been the sectoral applications like agriculture, hydrology, aviation, marine, urban, you take any name. Anywhere you can find out the utility of the satellite applications to optimize the weather and climate informations and to minimize the loss of lives and properties, be it now the environmental monitoring. Now, just to little understand how it is working, you will find that the first block of weather forecasting is the observations. Then it comes the modeling, then forecasting, then early warning generation, presentation, dissemination, communication to the last mile. So while considering all these blocks of the weather forecasting, you'll find the first block is the observations, which is very important because the meteorology is a science which is called a nonlinear science. It is dealt with nonlinear differential equations. There is always approximations. It is based on the assumption that it is an initial value problem. If you can have initial value correct, then forecast can be correct. And as of now, we know that 3/4 of the globe is water. And it is not possible to put up the observations there. So therefore, satellite comes to picture. Satellite provides the data and information throughout the globe, whether it is hills or the deserts or the water, etc. And these information are digitized and utilized numerical weather prediction models to provide the forecast. At the same time, real-time information is mapped and it is utilized by the forecaster to provide short-range forecast and mid-range forecast. Some of the success stories, as of known, that cyclone and others that are seen. So therefore, the observational gap which was there, as I told for the cyclone before 1960, many missing cyclones are there. And now there is no missing cyclones. But still, because of the limitation resolutions, etc., in the recent history, in 2006, we missed a cyclone in satellite, the cyclone Agni near Andhra Pradesh coast, which is crossed near Machilipatnam. It is because it was a small cyclone, it could not be detected by the satellite. It was detected by the radar. So therefore, all observations, as our secretary was telling, they complement with each other. Whether it's completing 10% or 15%, 20%, you cannot neglect any information, but satellite plays a key role. And after that, I want to say that various types of array of models we are utilizing, and different models we are utilizing satellite data along with the other data. Now, these are the various types of data. I just want to know that, I want to say that early warning is the first and foremost step for disaster risk reduction. In the early warning, when you say warning is being provided up to 5 days globally, India also provides warning for 5 days. In this early warning, we utilize models, various types of models. In these models, satellite data is playing a key role. In future also, it will provide a key role if you want to really improve, considering the 2047 target or considering the various global visions of satellites, if you just look at what WMO and others are planning for. The need for satellite data, if you just look at, I have just told you, the data sparse region, especially Indian region, if you just consider, it is a highly data sparse region. We've got the Himalayas to the north, we've got Arabian Sea to the west, Bay of Bengal to the east, and Indian Ocean to the south. So therefore, such a data, in addition, we've got Eastern Ghats, Western Ghats, Garo-Khasi Jaintia, Myanmar Hills, so many. They are data sparse regions, therefore, satellite plays a key role. Now let us look at the data assimilation. Yes, we are utilizing various data sets, including Indian Space Organizations, then HUMATCAST, etc., and satellite from various other sources through CGMS, and etc. And we are going to have an AOSUMC in the next December. So you will find out. But what I want to say that, as others have told earlier, 90% data are being utilized, but that 90% is the 5% of the total data collected by the satellite. So we have to ensure there is a very, very good scope for the beginners, researchers, academicians, and our industry partners, that you can convert the data into value. Just like petroleum being converted to petrol. There is a lot of data available. And as for the understanding with ISRO and IMD, we have got a lot of data, we have got the storage of data, data are available freely, you can utilize this data. Now this is the daily observation report. Just imagine how much data are being collected from the satellite and being utilized for everyday forecasting. So this is the accuracy of the data. You can see that impact percentage. You will find that satellite plays a dominant role, as I told you, in each individual. Be it geo, or be it is LEO, be it is polar, all are contributing towards the improvement of the weather forecasting. And you can see how it has improved the data assimilation in the recent years. Just I put up the one. There is a sharp increase after 2015 in data assimilation, of course, due to HPC and many other initiatives taken by the Minister of Earth Sciences. So this is another thing I want to highlight, that is impact-based forecasting. Yes, just 1 minute I'll take. Impact-based forecasting. So now nobody talks about the weather forecasting. Everybody wants to know what is the impact-based forecasting. Say, for example, when the Kerala point comes up, people ask, whether they've given the warning for landslide, whether they've given warning for the red color warning, whether they've given for yellow or orange color warning. So all these things are the impact-based forecast. We've introduced drastically. Implementation was taken up in 2019. At district level, station level, India Meteorological Department is providing impact-based forecast. When you go for impact-based forecast, there are 4 components. One is the meteorological hazards. Second is the secondary hazards, maybe floods, landslides, etc. Third one is the geospatial information. And fourth one is the socioeconomic indicators. So these socioeconomic indicators and geospatial information, these are highly dependent on the space technology. And we are utilizing NRSC data in our impact-based forecasting and other data also. There is enough scope to improve further. This is the scope for especially the heavy rainfall. We prepared this one. And you can just think of what are different types of layers where we need data to have a realistic impact-based forecast at very granular level. And target is the early warning for all. Each household should have the information about the weather and its impact, and hence they can minimize the loss of lives. So just as an example, hydrometeorology, I'll just skip, there is no time. For example, this is the plasma guidance provided for 1 kilometer to 1 kilometer. How is it being provided? It is based on soil moisture taken from satellite. It is based on rainfall data taken from satellite. Whether HE or AMRE, different types of products are being generated, that is being utilized here to develop the plasma guidance apart from the models being utilized. Similarly, agriculture, already Secretary has told, there are many products utilized from the satellite to provide the agricultural support for farmers. The climatology, I have already talked about the large-scale processes like El Nino, Southern Oscillations, Meridional Oscillations, and very convectively coupled equatorial waves. How do you monitor, for example, Rossby waves? How do you monitor Kelvin waves? All the waves can be monitored only with the help of the satellites. And I'm just given this example. I'll stop here because there is no time. One point I just want to say, the inside data sharing. We are the custodian of meteorological data, satellite meteorological data. We have got the good server and good archival server. We are providing data. I urge upon all of you, please utilize the data. We are providing you free of cost for research purpose, development of the technology, which can be utilized for the common man, which can further improve our detection, which can further improve our forecasting, and hence minimize the loss of lives. So these are some of the participation I've just highlighted here. But there are still gap areas. You can see that we need finer spatial and temporal resolutions. If we compare our satellite with other satellites, we are lagging behind. So we have to fill that gap. When we talk of 2047, we should be at least ahead of other satellite service providers instead of becoming again lagging in terms of the horizontal resolutions, etc. So the basic objective is the flash floods, cloud bursts, hailstorms, squalls, thunderstorms, which are still going undetected. It is not detected fully by the existing satellites. That's the operator brains. Now, constellation of satellite spectrometer, I will not discuss it. Already my work has been simpler because of So now, global all-weather vertical profile, that is, Secretary has already told, we need wind, temperature, and humidity profile. These three, if they are there, along with other three parameters of ocean, the forecast can improve like anything. The constellation of cloud and precipitation radars, these are also essential requirements. Already you have told me that the committee has submitted a report and ISRO is considering seriously, and we are going for INSAT 4 series. That is the need of the hour. Now, this is the requirement of 4th generation satellite. Already Joseph has told. I will not repeat it here. Now, I will stop here. If you have any questions, you can go further.
Thank you very much, Dr. Mahapatra, for a very nice illustrative presentation and highlighting the various applications of satellite data in meteorological and climatic services, which is being provided by IMD. We can open the floor for at least one or two quick questions or observations.
Yes,
actually, as a part of training, I visited IMD Pune. At that time, we were shown for forecasting, they used to show in 90s, actually, regression modeling they shown us. I think now we have improved.
Now we have dynamic models. Not one model, we have got the different 10 dynamic models are considered.
Now, what is the percentage of accuracy?
It has improved significantly. In the last 10 years, if you just look at that, we have quantified, there is 50% improvement in forecast accuracy of all severe weather events as compared to previous decade. 50% improvement. Huh? Improvement is 50%. Say, for example, I will tell you, if I say tomorrow there will be heavy rain, if I say it is 80% now, which was around 50% 10 years before. If I say cyclone, I should not talk about cyclone. People will say, cyclone man. You know, everybody knows what is the success story of cyclone. It is a national success. Everybody is what's that? This forecast is a pinpointed forecast being provided, be it Viparjar, be it Fani, or be it Hudud, or Phylin. You have seen all these things.
Thank you.
Be it lightning. Yeah. Lightning forecast being provided now. It is a success story from 2019. It has started in country. There are 5 countries in the globe only who provide lightning forecast. Yes. Thunderstorm accuracy is 86%, 3 hours in advance.
Yeah, I think we have done a wonderful job as far as the improvement in our weather forecasting services are concerned. In spite of having, large amount of satellite data, still there is a need of, more analytics on this data so that this gap can also be bridged. Even though, we have made significant advances, but nowadays, in case of, extreme weather events, still we are, we have to work much harder to provide early warning system. So I urge this community, especially the younger guys sitting in the back and our industrial partners to associate with IMD. Even ISRO is providing these free data sets. Data is not an issue today. More utilization and analytics is basically what we should look forward. Thank you, sir.
I just want to say one sentence that I should acknowledge and appreciate and mention here that whatever I presented, this is not a presentation of IMD only. It's the presentation of entire community.
Yes.
In Space Organization, National Center for Forecasting, IITM, INCOIS, NCR, everybody. All are involved there because this science, which is the Earth system science, involves everything: hydrosphere, biosphere, cryosphere, atmosphere, everything. So
Let us.
Everybody's contribution is printed here.
Thank you, sir. Let us give a very big round of applause to our speaker, Patra sir. Now, may I invite Dr. T.M. Balakrishnan Nayarji, he is Group Director, INCOIS. He will be talking on space applications for ocean. Bala.
Thank you, Chair, distinguished delegates, and my colleagues. I'll be giving a brief introduction on the application of the satellites or space for the operational oceanography, which is that INCOIS does for the benefit of the industry as well as the common people. So you know very well that we have got the ocean challenges. We have almost 10 challenges identified by UN. So that starts from the clean ocean to the productive ocean to sustainable ocean, which we talk the blue economy. And there is so many challenges exist. So the most important problem for this actually the observing the oceans. So we have a global body called Global Ocean Observing System. In that we have a combination of the in situ and satellite the programs. So to be very precise, told by earlier speakers, the satellite is a main source of data for the oceans, because ocean observation in situ is very risky as well as the very expensive even. So we are looking for the global, I'm talking the global ocean communities looking for the data in a much the spatial and temporal accuracy, which is not only for the research. Now, the ocean community is actually changing from the ocean to understand, or oceanography to understand, to the oceanography for the predictions and services. So this, the satellite is a very important tool. And we, as an oceanography community, we are working for the observation co-design and observation observe together and predict together. And I think the space community, we are looking for with a lot of expectation for the get more operational satellite missions. So we know that we have a lot of satellite missions, and we receive the data at INCOIS, even if it is OCM or it's a Saral Altica, NISAR, which is coming on. So the global ocean community has identified many of the parameters that is called essential ocean variables or essential climate variables. So many parameters, like for example, sea surface temperature, we told about sea surface wind, or sea ice. Some of the things are well observed, and we have a very good data which can be directly used for our modeling system for the providing the services. But still there is a lot of lacuna. We see that the biogeochemical as well as the bio-ecosystem observations, actually that is something our request for the oceanography, this space community, for better the satellites which can observe the biogeochemical as well the biological parameters. So INCOIS, when we designed the, in almost 24 years before, we designed for a institute for a operational oceanography, mainly taking care of the ocean, the space applications, remote sensing application. We know that we started from the potential fishing zone services. That's a direct application for the fisherman community. So now when we stand here, we serve almost all communities including from fishermen, our navy, ports and harbors, coastal state and fishing community. And Mahabatra Saab already told, we are also looking for impact-based systems, impact-based forecast, which is actually the industry can really take up. So to come a little bit much forward way, we are actually utilizing all the ocean satellites which is received at INCOIS for the potential fishing zone, coral bleaching alert, ocean state forecast, storm surge warning, and all other things. And we assimilate almost all data, but unfortunately, we have less satellite which can be operationally used for the ocean the forecast purpose, but we are with a very high number resolution. So going back to the challenges, we have a lot of products. We see that the clean ocean, that is the water quality forecasting for the Indian Ocean, or oil spill forecasting, or the harmful algal blooms. These are the operational products available from the oceanography community, and we utilize the satellites in day-to-day basis in INCOIS. So another the challenge is actually the safe oceans. So we know that we have a daily forecast product coming at a different time and spatial resolutions for all the essential ocean variables. But we also have the impact kind of forecast, which is as a combination of many essential ocean parameters. And we also converted this one to early warnings like tsunami, storm surge, sea level. So here I am not going to individual satellite, but daily basis the utilization is very huge. So another important thing is the essential climate variables. So Goose identified almost 30 essential ocean variables. I think many of them are very important for the climate predictability, and we know very well that we have a deep ocean mission. Then there is a climate variability for the ocean climate services for the oceans. It's very important, and we identify many parameters like sea level rise, cyclone intensity, and the storm surge intensity. So here we should actually also plan for many satellites which can serve the purpose. So another important area we are looking is actually low-cost communication system. We know that unlike the land area, when the industry or the fisherman community goes, they don't have the device to receive the information. So we actually, ISRO and INCOIS has come with many NAVIC systems and the Gemini systems, but still it is not accessible to the community. I think we are also looking for better systems. And Silas Saab already told in the morning that blue economy, that is the challenge for the Ocean Challenge for sustainable blue economy. So the INCOIS is going with many products which can be directly used by the industry like oil, shipping, or the maritime boats. So, but the thing is that again, we are also looking for the operational kind of satellite, except we have got OCM2, but we require, for example, the Altica, which were regularly we are used by that, but this replacement for that kind of satellite, I think we should think about. So we know that we have a blue economy draft policy. It is coming with a big way. So we should be prepared for that. So this is something we estimated for the what is the economic benefit of all the services, including the satellite services. So concluding this, as I told that we are not we are actually transferring or transforming from the oceanography to understand the oceans to oceanography to predict and service the ocean community or maritime community. So we are actually looking for the operational satellite constellations. So the industries here present, I think they can help very well for us with nano satellite and other satellite, because the satellite which is available all over the world, I think it is not really we are reached into a position that we can actually use it very well for the ocean forecasting purpose. Especially for when we are assimilating for the ocean currents and ocean waves like that, but we should have a more satellite like that. And also like that, we should have an integration of the satellite and the in situ observations and better algorithm for the parameter retrieval in the coastal areas where most of our the maritime community require the satellite information. Also, we have to identify the essential ocean variables to essential operational variables, and the satellite community also has to be thinking about how we can serve it more. And of course, physics, we have a better coverage from the satellite, but marine biogeochemistry and biology is another priority area. So we are looking for observed together, better stakeholder engagement, and serve together ocean and atmosphere, space community to the marine community. Thank you very much.
Thank you, Dr.
This
Bala.
is not to advertise my paper, but this is an area where how your satellite as well as the in situ observation system can combine to have some challenges.
Thank you very much. Since we are in inquiries, you can always have a discussion on ocean aspects, maybe during lunchtime. But let me tell you that remote sensing is essentially, we call it for remote, locations. So oceans cover almost 70% of the global Earth's global area, and the maximum amount of information about our oceans, oceanic processes has come from satellite observation. So in that context, continuity of the future satellite observations for oceanography is also equally very important. Thank you, Dr. Bala.
Thank you, sir. Thank you, sir.
Now, we will move on, and I would like to invite Dr. M.V. Ramanamurthy ji for his talk on space applications for the coastal regions.
Thank you, Chair, and then Dr. Bhattabi, and then all the center directors, colleagues from INCOIS and various institutions, students, and the industry. I think because whatever has been told by others, I won't repeat on that. Coast is important basically for two reasons. One is the resources are all put to the stress because of urbanization and population. And then second one is about the climate change. We have impact on that. I'll briefly touch upon these are all some of the resources what we have over a period of time, but now with the improvement in the satellite communications and then also on the satellite data, how do we analyze, especially on the resources, how they have changed over a period of time, but also on the same time, how to mitigate the disasters. In fact, many of the applications what has been directly applied for the coast, I will highlight here. And basically, we work on three areas, especially on the marine pollution, because satellites are important for monitoring the marine pollutions along the coastline. And then this is very important for the fish production or fish migration, whatever it is happening on the sea. Second one is about many of the areas are subjected to coastal erosion, and then satellite data, we can tell that like you go and then what is the problem for the coastal erosion. The diagnosis can be done more meticulously using the satellite data, which gives a long-term information on that. And if you want to have a good ecosystem all along the Indian coastline, you need to have a biogeographic information system. Satellite space important role. Of course, we also have in-situ observations. Last part is the climate change. I think we have to live with this, and then now I think Dr. Mahapatra has talked about what we call for the warning system, but now people are looking for adaptation. Suppose if flood comes, okay, every time we give the warning, but also how the city is to prepare. Like Hyderabad get flood, Delhi get flood, how to mitigate from that? Where the space technology can be used for adaptation for that. On the pollution, I think this is a picture which shows at one of the place in Pondi, and then we also have algal bloom, and then this is not algal bloom, this is basically a dye which was released, and then we try to monitor and then to recognize that it took a lot of information. In fact, I was sometime back, I was discussing with Dr. Prakash Chauhan and then see how marine pollution can be monitored from satellite data, and then finally prepare an action plan for abatement of marine pollution. Similarly, on the outfall which is discharged in the sea, it has its own dilution, and then the satellite data is very useful for analyzing the pollution dispersion in the sea and then what impact it has on that. Already I talked about, Balakrishna has talked about algal blooms, and then of course we have to make a distinction between algal blooms and other pollutants. There are many sensors which is available in the satellite. We can differentiate between these two pollutions and then see how do we can utilize for that. Last part is, I think this is one of the important areas. Still we have not developed with that, maybe over a future. Marine litter is one of the means to the many of the coastal community. How do you monitor using the satellite data? Of course, drones have been used, but satellite data will really help in, suppose if you develop any policy, how do we evaluate this policy in terms of mitigating the marine litter for that? This is the flood map which was prepared after the tsunami, and then we have further almost all areas for the tsunami has been mapped by INCOIS, and then these maps directly go into INCOIS to predict the impact-based forecasting on that. Next one is, I think we are working with IMD. I think Mahapatraji has already told about that early morning for the flood. But now slightly our trend has shifted to how do we mitigate this in planning, urban planning or mitigation of these floods in the many of the areas for that. People are looking for what kind of data which we can use to see that how this catchment and urbanization has deteriorated the entire area, because earlier we used to get a rainfall of let us say 20 centimeters spread over 1 or 2 weeks, but entire 40 centimeter falls in a short duration. How do we empty this water and then see which is free from the flooding for that? In fact, some of the strategies for urban areas which we are looking using ALTM and also from the other data to see and then plan for the mitigation measure for the urban flooding, and then how do we adapt ourselves for that. This is about the flood warning system which was developed for Mumbai and Chennai, but lot more to be improved on the precipitation when it comes for that. I'll tell about the coastal shoreline changes. I think Dr. Thomas has told about the Shar itself island got eroded, and in fact we asked NRSC to give a data of last 30 years, and then the diagnosis was very good, and then see this shows long-term data, how it has been useful for analyzing the shoreline change and then forming a mitigation plan for the Shar coast. Hopefully by another 1 year time, Shar Island will be having a mitigation measure. It was all done through the scientific data. I should say that whenever we go for any diagnosis of the problem in the body, you go for X-ray. Satellite is nothing but what we do X-ray of a long-term data and then see what kind of solution that we can provide for that. This is some of the discussions about short-term, mid-term, long-term and all. These need to be really analyzed in view of climate change, and then these spatial scales vary with respect to the what processes which are operating both natural as well as man-made. Satellite data is found to be very important for that, and then this shows state-wise what is the coastal erosion along the entire Indian coast, and we repeatedly analyze this data over a period of time, and then in fact there are several tools using the remote sensing. We can analyze the inlets, how they behave, and then what kind of mitigation measures which will work on it. With all these things, thanks to the space, we had come out with a shoreline management plan for the many coastal states. How do we plan our developmental activities, balancing the climate change as well as the urban development for that. And this helps us in improving that. Last but not the least, like this, when we want to monitor ecosystem, any place, whether it is mangroves or corals, all those things nowadays we can using the satellite data. Suppose if we want to mitigate or adapt from our climate change, these bioshields are important, and then space applications plays a very important role in developing this kind of bioshield in this area, and also to study if you do a bioshield, how it will mitigate from the climate change impact on that. This shows about the how do we develop for Tamil Nadu. In fact, this project is already on, and then hopefully Tamil Nadu will have a bioshields which is developed as a part of this exercise for the climate change mitigation for that. And this shows about the map we analyze for the coastal areas, and then see after incorporating these bioshields how this coast is adaptable to the climate change for that. This shows about the detailed analysis of bioshields along the last. I think he was talking about when we want to go for the coastal regulation zone. All these things are mapped using the satellite data, whether it is CRZ1, CRZ2 or that. But now where do we stand now? I think it was talked about blue economy. One of the important areas is marine spatial planning. So far we have been doing planning only on the urban areas using the satellite data. We'll try to do in the ocean also and marine spatial planning, and this see that what kind of data which goes into the system, and then how do we plan the activities in the ocean to support the blue economy without having any damage to the ecosystem in that area for that. This has already been advanced stage, and then hopefully once the blue economy policy is released, and then this will be implemented at each and every state. Right now we are doing up to only 12 nautical miles. We'll go beyond 12 nautical miles up to EEZ. where the space data plays a very important role. This is all done using the satellite data. In fact, whenever we get a problem, first we'll do only 50% analysis using satellite data, then we'll supplement with the in-situ data what is to be done for that. I think this shows a conclusion on that, and then lot more to be done on that. In fact, satellite data is one of the good diagnosing tool for the analyzing any problem, not only for analyzing the problem, but also for suggesting a mitigation. Thank you.
Thank you, Dr. Ramanamurthy, for a very nice and crisp presentation. Let me just inform all of you also that many times you must be reading that India has a coastline of around 7,500 kilometers, but a nationwide, high-resolution satellite data, along with Survey of India and other agencies, has revealed that now we have additional 2,500 kilometers coastline, and the new number is now likely to get notified around 10,000 kilometers. So a lot of more work is required to be done for this additional 3,000 or 2,500 kilometers, and I urge this community to take this activity on a priority basis because this is linked with our economics. You can discuss it, sir, during lunchtime, otherwise you will not be able to have lunch. I think this question we need not entertain over here. Thank you, sir. And let us give, a very big hand to Dr. Ramanamurthy for making a very crisp and interesting presentation. Now I call upon Dr. Thamban Mello, Director of NCPUR, for the last presentation of this session on the cryospheric applications. Over to you, Doctor.
I am between you and lunch, so I won't take much time. More importantly, yeah, I'm also been blamed actually that we talk about topics which are much beyond your close neighborhood. We always talk about subjects which look so remote. But unfortunately or fortunately, the things have changed so fast and so much that it's no longer so far away. And most importantly, that whatever we understand actually in those areas, what we call as cryosphere, where water is in frozen form, whether it is sea ice, whether it is land ice, whether it is frozen land, whatever it is, the space observations or earth observations is the one which made it possible. Whatever we know about those regions now, the changes in Arctic sea ice have been drastically decreasing, or Antarctic sea ice, which has been increasing for a quite long time and then suddenly dropped. So all this information we got to know because of this space information. And even what we understand currently in Antarctica, actually the loss of the West Antarctic ice sheets being drastically decreasing is also basically from the space information. And that includes the Greenland, which is in the Arctic again. The Greenland ice is contributing so much that about nearly 300 gigatons of ice it's being losing per year, which essentially going to increasing the sea level, which is nearly double than that of Antarctica currently. But in the coming decade and coming decades, further decades, actually Antarctica is going to increase in a much bigger way. So all this not only going to change your the sea level, but also it's going to change the way the climate is going to function. And the precise mapping of Antarctica is what actually recently helped us to understand that actually the West Antarctica is decreasing ice mass in such a large way because of the help of the laser altimetry. And we have seen that actually the increase is so drastic in the recent last 1 decade along some of the Pine Island as well as the Thwaites glaciers actually. It is even potentially possible that actually those ice sheets sitting on the West Antarctica, which is on my right hand actually, could be lost completely. That would be the huge difference it makes to the sea level change as we know from today. And it has been, of course, used in understanding the glaciers, which is closer to our neighborhood actually in the Himalayas, the loss of glaciers through time period, the retreat of glaciers. And more importantly, the retreating glaciers are also contributing to hazards, especially some of they are forming a lot of lakes. As the glaciers start retreating, you have the formation of these lakes, and these lakes keep expanding, and there is a stage of vulnerability where after some, any large precipitation or changes in the mass or the breakaway of any part of the glaciers can lead to the breach of these lakes forming what we call as the GLOF, the glacial lake outburst, which we have seen recently in case of in Sikkim and in other parts of the Himalayas. And this is going to increase drastically from now on, because actually almost many of these glaciers do have this kind of lakes. And again, the space application is what made it possible to track them, because in the recent times, and that's going to be the mainstay even if you want to have an early warning system. Of course, you will need to have a ground actual instruments, but it would ultimately space information will require on a what you call the live information for that. And the passive micro sensors, which made the real important difference to what we know what happens in Arctic and Antarctica, which clearly showed actually nearly 50% of the Arctic ice is already lost, making it possible actually Arctic is going to be open for the shipping navigation, open for more resource exploration and exploitation, and so on. And such greening, such retreat or the warming of these polar regions also leading greening of the Arctic, which are ultimately making large part of these Arctic regions and the polar regions are becoming more and more greener. So what happens in the polar regions ultimately does not stay there. That's the statement which I want to make, because polar warming is impacting all of us, not only through the increasing sea level, but also the drastic the changes in the climate which we see today, especially the extreme weather patterns which we see, including in rainfall, extreme rainfall. It is proven to be that now it has a direct connections to Arctic regions. So therefore, the Earth observations are going to be the key to assess this change. And it already has revolutionized the way we understand actually the science of the polar regions, the operations being undertaken in those areas, as well as how do what is the role in climate change studies. So basically also they also improved the climate models. They enabled us to understand the impact of this cryosphere on the global systems. And they also provide the baseline data to understand the linkages between what happens in the polar regions and the tropical regions, how they're connected, because you require large-scale data for that, and for a long-term monitoring for that matter. So it also facilitates a real-time tracking of some of these regions, especially sea ice regions in Arctic and Antarctic. They become very useful for the operational activities. This is one example actually which clearly shows that actually that there is a clear mechanism now that what happens in Arctic does not stay in Arctic. It affects our climate system. And it also shows that actually that in case of Antarctica, as the sea ice is drastically decreased since 2016, there will be a lot of expectation that will start again increase as it's part of the natural cycle. But it seems to be getting into a situation where things could be worse, because it's probably may not be able to come back to its previous stage, because the multiple factors playing around, because there's a consistent the ocean warming, atmospheric warming, and there is a record of this deepening of many the polar cyclones and these what you call the atmospheric rivers reaching to Antarctica. All this is making actually the health of sea ice around Antarctica is no longer safe as we expected in the past. It's also probably following the pattern of what is happening in Arctic. So, so the new generation satellite actually, especially for example, the EOS-4 actually for that matter, so the SAR interferometry has really helped us to getting into the real high quality data which we never had access in the past. We still don't have a long-term data from Indian satellite data, but I think we have to made an initiative now which provides a very high quality data now. I think this is something which we need to, if we continue in the future, we'll make sure that actually we will be able to monitor some of the systems. Even this is very useful, especially if you want to study what happened to some of the new formation of polynyas in the sea ice regions, because they decide how the sea ice is going to be remain there or not, how the productivity is going to be change in that area, and so on. So what I want to say, this is my last slide before you take the mic. So Earth observations offer the key to the assess the polar cryosphere, its interaction with ocean as well as atmosphere. We also want to point out few challenges we face at the moment and what we consider as priorities. Because, for example, the measurement of sea ice, one is the biggest problem actually, the large amount of snow sitting over these sea ice, which makes the measurements inaccurate. So the measurement of snow depth over sea ice are very challenging, but are going to be extremely important if you want to have an accurate mass balance as well as from the altimeter derived sea ice thickness data. And we would require improved sea level estimates from this, again, altimeter data, because there is a seasonally ice covered regions are going to increase in these, in the climate change scenario. And there's also a requirement for increasing resolution because, you know, both temporally as well as spatially, because if you want, there are so many unknown small scale processes acting in these regions now, which play a large role in the internal variability of cryospheric components. So that would require a closer monitoring. And monitoring of phytoplankton, biomass and productivity in polar waters also require better calibration. That's something, the big problem in the polar areas, where the data is a big issue. So addressing data gaps, as well as in sea ice and clouds, integrating various sources of possible available data for accurate measurements are going to be very critical. Finally, also say that actually we need to develop a standardized framework for integrating satellite data in the ground-based observations, especially in the polar region, which is relatively less developed than the rest of the world. With that, I leave it here. Thank you so much.
Thank you for an excellent overview presentation on the use of Earth observation data sets for cryospheric application, including north and south poles, as well as you know, a lot of work NCPR is doing for Himalayan cryosphere understanding also. I am not sure whether anybody has any pressing questions, so let us thank Dr. Thamman with a round of applause. And let me you know, end this particular session by inviting my co-chair for giving a very brief, you know, quick summary. We had powerful 5 presentations and very nice take-home messages. Maybe if you can just highlight 1 or 2 points.
Thank you, sir. And we have an excellent technical session on, we have 5 presentations. First presentation by Thomas, where he has mentioned about the current status and future satellite missions that are coming up for Earth system science applications. And he has mentioned about the future satellite missions that are going to support Earth system science applications. And then followed by, we have a presentation by Dr. Mohapatra, where he has covered about the current status as well as the gaps and challenges and the future requirements as far as meteorological fraternity is looking forward. And then we have 2 presentations covering the oceans and coasts by Bala and Dr. Ramanamurthy. Basically, Bala has mentioned about the current status of the ocean observing system and also the requirements as far as sustainable development goals are concerned, where he has addressed the challenges and the requirements as from the point of view of the ocean observing system on a global scenario, where he also mentioned about the essential ocean variables. We have to move towards the essential operational variables, because now blue economy is going to depend on the services that are being provided by the oceanographic community, particularly the operational oceanography, when he talked about INCOI's services. No, and these oceans cannot be covered by in situ observations, where as we have in the plenary inaugural session, one of the speakers mentioned that satellite remote sensing is going to be the mainstay of the observation. So that, I think that is the one major requirement where we have talked about the oceanographic applications as well as the coastal applications Dr. Ramanamurthy has mentioned. And finally, Dr. Thamman has taken us from the seas around us towards polar regions. As he mentioned that we have a large impact on this polar from the point of view like the climate, the sea level change, and the requirement of satellite observations, particularly to monitor this cryosphere, and also has raised the issues, the gaps, and then the future requirements to address these cryosphere things. So we have excellent session with eminent speakers here. And I would like to thank all the speakers for giving an excellent insights into the various applications and gaps, addressing the gaps and giving us the future requirements. And I also would like to take this opportunity to thank Chair Dr. Prakash Chavan for presiding over this session. Thank you, and I think we are not going to break for lunch, and we are going to continue the session, and I hand over it to the organizer. Thank you.
A sincere thanks to our session chairs for keeping the conversation on track and creating an engaging atmosphere for discussion. Moving forward, we have a panel discussion with industry partners and space startups. They will discuss the latest developments in space technology applications and the future of space missions. We welcome Dr. J.V. Thomas, Director EDPO, to chair this session, and Dr. Anish Lotlekar as a moderator. Please take over, sir.
Good afternoon to you all. So I'll be very quick because I know you are just waiting for the lunch. So I think over the day you must have heard all the speakers talking about the importance of the space-based sensing and its various applications, which contribute significantly to the country's socio-economics, which was said to be roughly around 2 to 4% right now and envisaged to be 10% by 2047. So to achieve this, we really need support and participation from the various space tech industries. So moving forward in this direction, we have organized this panel discussion to understand the role and plans of the industries and various startup companies to strengthen the Indian space program. So myself, Anish Lotlekar, I am from INCOIS and moderating this session. And I welcome Dr. J.V. Thomas to chair this session, and so please be on the dais. So Dr. Thomas is a senior scientist from ISRO headquarters. And I personally know him as mainly the bridge between the space tech and the application through various ISRO MOS collaborations. So these sessions we have broadly categorized into 3 tracks, which we call like space applications, satellite electronics and communications, and launch vehicles. So we'll hear one by one for each track. So for the first track, I would like to invite the industry's representative from, so I'll just call out the name RIMT, Adapto Geoinformatics Private Limited. Or, hi. Okay, nice. Representative from GeoInfi Solutions Private Limited. And from Greenco Group. And RSI, representative from RSI. Okay, so now I hand over the session to Dr. Thomas to chair.
Caller might be and everything working. And RSI also is in 1985 you have established, and data acquisition, surveys, data processing, geospatial data analysis, everything is your mainstay of the thing. And GeoInfi is data interpretation, agriculture, disaster, climate change, natural resources management, all this thing your mainstay. So
maybe we will request you to speak about, I mean, slightly touch upon your work, and also you can also in the same speech itself you can also include this how can you contribute to the geospatial data and application for the societal benefit, how you are planning something you can mention about the natural resource management, disaster mitigation, etc., what you can contribute along with the other government agencies, how can you, and what is your future plan? Just, but don't, I mean, the time allotted is 3 minutes. We will quickly break for lunch. So I'll start with, maybe interim I will start with.
Hello. Yeah, good afternoon, everybody. I am Naveen Kumar, representing INRIMT, Indian Resources Information and Management Technologies. It was established in 1992, actually. Now we are talking about all startups and all that. And Dr. Chauhan also mentioned that in recent 2.5 years, there are about 100 and 150 startup companies have established. But during 1991, ours was the startup that time. But that term was not there. Taking the call from Professor U.R. Rao, then our chairman, he was working with ISRO. He came out of ISRO and started this company, mainly to commercialize the satellite image, satellite technology, and we wanted to take it to the grassroots levels those days with the available spatial resolution. We have the experience of working from 72 meters to nowadays the 30 centimeters spatial resolution data sets. So we extensively worked in the areas of natural resources management, and when we generate the database and not only on natural resources management, we also provide the management solutions. So this is our background, and we are into now the artificial intelligence and then machine learning also. We are in the process of coming out with the solutions. Especially we wanted to work in the areas for the societal benefits like, crop insurance, then damage assessment, all these things. But sometimes, we are facing a lot of problems for the high resolution satellite imagery. As the Indian satellites, they provide only 1 meter satellite resolution. We are depending on the foreign satellites. And there are a lot of restrictions. As private player, we cannot immediately access the satellite data. A lot of screening has to be done. But now, I just would take the opportunity of this occasion to request the community that some more relaxation needs to be happened, because many players, they are using drone images, they are flying and taking the pictures for analysis. Because many of the customers, nowadays they have become more intelligent and they want the results in overnight also. So we cannot wait for the satellite imagery to buy the satellite data. We are taking high resolution. I'm talking about high resolution, maybe 2 months sometimes if it is a fresh tasking. So I would like to request the ISRO and the data policy makers to further relax the data. Now we are doing all the AI-based analysis for the crop acreage estimation, then damage assessment and all that. So this is briefly background of our company, and ours is 30-year-old company, in fact.
Thank you. Thank you. We will separately talk about when you talk about the relaxation, further relaxation. What is that you mean? We will further discuss and come up with.
Good afternoon. This is Suresh Bethpudi from GeoInfi Solutions. We are 1.5 year old company. We started from T-Hub. Now we are expanded with IIT Tirupati, and we are close collaboration with them. And basically, we work in agriculture, disaster and climate risk, which is my core area, especially in modeling and natural resource management. So far, in terms of agriculture, we have developed from monitoring to yield prediction with machine learning models we have developed. For disaster and climate risk, we are working on solutions that can be implemented on the ground. Recently, we tied up with IIT Tirupati to develop a kind of micro remote sensing based, land deformation system, so that it can be useful for any kind of landslides, whether it is natural earthquake or kind of rainfall induced. So we are trying to develop it, and we are in the process of it. Since it is very recently, established a company, so we are looking for close collaborations with government and public agencies. In terms of data, we are leveraging data from satellite-based information much in our models and parameters also. We are deriving from satellites. And we are assimilating in our models, basically for, suppose if we take a cyclone model. So we are integrating our kind of land use, land cover, and all this information. We are developing roughness parameters and terrain coefficients to integrate into our models. So basically, what I am looking from my perspective is that what Sir said, little bit liberty towards the high resolution data in terms of data as a service kind of thing. If you can provide to us, that industry can leverage easily and integrate into their models. The other thing is like, you see, everywhere, we cannot go and do a kind of survey. So you might have done under the government programs and everything. If you can release such kind of data to us, we are going to leverage that public information as well, survey data basically. And we do also do a kind of object detection, deep learning models. So if you can provide such kind of some training models from the satellite images, whatever it may be, that is useful for us to train our models, or we can reinforce our models on top of your trained information, and you can release. Particularly, I am interested in microwave remote sensing, so I am looking for the NISAR satellite to be launched. If you can give some capability or tools to process the information, SAR interferometry, so that I can easily integrate into our models is a good proposition from my side. Thank you so much.
Thank you. So basically, you were telling about the relaxation in high resolution data availability also, if you can get it free of cost, or ISRO satellites, that is one thing you have told, and also the training we can easily think of for training for a new tool.
Can I start?
Yes, sir.
Yeah. Good afternoon, distinguished guests and delegates. I'm Bhaskar Kannoju from CEO and founder of Adapto Geoinformatics Private Limited. It's a 14-year-old company. So my professional experience is 25 years with the geospatial industry. And my company is 14 years old, and I am into geospatial services and products as a premium partner for Hexagon Geospatial products, and more importantly, high resolution satellite imageries, which is Maxar from USA. So from the last 2 years, today's topic is, the use of space technology. So from the last 2 years, we have been sold more than 400,000, that is 4 lakh square kilometer for 35 clients in India itself. So they effectively using the space, high resolution satellite based technology. So here I want to tell you, Maxar means formerly known as Digital Globe. They have a series of satellites from, if you are working from the past 1 decade or more than that, Iconos, GeoEye, QuickBird, WorldView 1, 2, 3, all the sensors are still available up to 50 centimeter, 30 centimeter, 31 centimeter, and native 15 centimeter HD. Not only that high resolution centimeter, they do have a derived products for ortho, DEM, DSM, and DTM, where you can readily use for your all space-based technology centers, like whatever today's we discussed all the topics. The more importantly is Maxar always supports in a greater geospatial community before and after any disaster happens. So we do have a product, we on a humanitarian ground also, humanitarian community, Maxar freely offers you the product where you can make use of the satellite imagery at free of cost on a disaster response. So that is freely available. Say for example, if you could remember, maybe 3rd September or Nepal earthquakes or North Indian floods or Libya floods, or maybe Morocco earthquakes, every data is available free of cost on humanitarian grounds in the Maxer portal. You just type it maxer.com/open-data. You'll get all the things. This is one. The other thing is that we do have on a humanitarian community, this is free of cost. On the other commercial aspects, we do have a product called Secure Watch. We do have a legacy data of 25 years, since 2000 or 1999, from all the series of satellite data all over the globe that you can effectively use for all your predictive analysis and modeling purpose. In addition to that, we do have a climate desk, which is recently open to all on a commercial model, where you can have this leverage. Climate desk can leverage all the national and international climatic modeling centers data for operational preparedness. So the most of the thing here we talked about most of the Indian launching satellites, but you can also make use of foreign satellites where you'll get better resolution, 24/7 availability, and you can use as a platform, data as a service also, these portals. Yeah. So a couple of months ago, we launched, we are supposed to launch 6 constellations as a Legion satellites, but it couldn't happen. Only 2 we were launched, so that it will available at least in a 24 hours on Earth observation systems. So this is what, we do have a high resolution satellite imagery up to 15 centimeter HD, 30 centimeter, 50 centimeter, and all DEM products with an absolute accuracy of 3 meter and vertical accuracy of 1 meter. So that's all about.
Yeah, thank you. Good that you in-rimmed, Adapto and GNF is continuously working, and several years of experience you are contributing to this thing. So we also, we also expect that you come out with your own solutions and come and speak to the agencies. Mostly now also government agencies are utilizing. So whether it is disaster management, NDMA, all this thing. You come out with the ready, solutions and come to us and talk to us, so that we can also take your solutions to the government, so that you can they can operationalize your solutions. Maybe the brochures or some other thing, if it is there, you can send it to us also, and all the government departments you can send and advertise your work. So. Yes, sir.
Yeah, sure, sir. Because the problem, most of them are not aware about these kind of facilities are available in India also. Because if you talk about climate decks, there is a precipitation, wind, and atmosphere. Every data is integrated with the multi organizations and institutions. Those companies' data is used in these platforms that you can leverage for climate desk kind of thing. And for others also, for free data is available as a community purpose to serve this disasters kind of thing.
Okay. So we, because of the lack of time, we will not continue the discussions. Maybe during the break time, we will continue to discuss. Thank you very much for participating in this.
Thank you, sir. Thanks for the time, sir. And thank you to the inquiry director and the staff.
So we'll call upon the next group of.
Yeah. So just let's move to track 2, that is satellite electronics and communication. So now may I request the representative from Dhruva Space, Avental,
Chaitanya.
Adista Industries, and XT Links Lab.
Dhruva, Avental is there. Yeah, Avental is Assista is there, and XD Links. Okay. Welcome to this panel of satellite electronics and communications. Again, as earlier you are also, is so much of activities we are doing. Dhruva Space, Mr. Chaitanya, your expertise in platforms, subsystems, and also you are planning for hyperspectral missions also, you are planning constellations, you are planning. And Avantel is planning for SATCOM services, and all is your mainstay, and assist small and nano satellites. And also for this community, it may be interesting, you are also doing in the upper air sounding, as well as drifter buoys, all these things are there. So it is, I mean, this community can utilize this information. Right? XD links also, you have got various platforms, several buses are there which can be utilized for incorporating our own payloads. So I request you to again, we can limit the time, keep the timing, and you can talk. Maybe I'll request Dhruva Space, Mr. Chaitanya to.
Good afternoon, everyone. So I'll go on a very quick tangent, sir. Apologies for taking the extra time. So even in schools, you have the kids, like the younger kids dancing first or performing, then you have the professionals coming in, like the senior ones. Here you did the reverse, which is very hard for us to come and follow up, where you had INCOIS, you had ISRO, you had IMD and CCR come and perform, and now you ask us to say, match up to them. I'll try to be as entertaining as possible. So we are a full stack space engineering company. We start from building the satellite bus itself, where other than the payload, rest of the platform belongs to us. We help launch these things where we have our own deploys, and finally we also have built the ground stations, and now we are also getting into ground stations as a service. Now coming more specifically to something, some of our offerings that might be interesting. So primarily when we started off, our thing is that if you want to run a cab service, it doesn't make for you to build the car. You want to buy the direct car and then you provide the service. So similarly, for most of the folks providing services from space or analyzing the data, etc., doesn't make sense for them to build their own satellite or have their own full infrastructure. So that's where we come in. So we are saying that you have an idea, you have the payload, or you want us to help with the payload, we'll do that. And we will make sure that the constellations are more reliable, they'll be more economical, and also we will be able to launch them at a much quicker pace so that the idea doesn't become defunct. I mean, a 5-year-old phone would seem completely redundant today. So that's where we are coming from. And moving from that, one of our programs is what we call LEAP missions, where it's a mission where you can, multi-payload missions where different people can come be part of it. So it's not necessary for the organization to completely own the satellite or work on it, but just if, I mean, it might not work for the full constellation, but at least to start off with, to test out the payload, to test out a concept, we can get there much quicker. Within 6 months, you have the payload, we can put it up there and we can test it. And even cost will be brought down because you have multiple people sharing the platform. And then we also are closely working with Kines. It's a spin-off of Argos program where currently we are looking at, with their launches, there should be around 15-minute gap, maximum of 15-minute time gap for communications. Again, M2M and IoT, low data rate communication, where we are trying to augment the full system by launching our own satellites and adding it to it so that we can further bring that timeline down. And finally, of course, we do provide the bus, so that can be done. And our we were actually building some concepts on our smaller CubeSat platform, where we were looking at GNSS occultation, etc., which I mean, today we are looking at much larger satellites doing it, but we can do it on much smaller platforms akin to what other countries are doing. So thank you for the opportunity.
Thank you. I mean, can you just about your hyperspectral constellation you are planning, any progress in that?
Sir, today we are still, it's in the very early
concept. And of course, there's the PPP that we are considering. We haven't still taken the full call on it because it is a responsibility more than anything else. So we want to be sure that it's done right. We are, in one of the LEAP missions that we are talking about, we are launching a hyperspectral payload for an Australian company where while we do not own it, we're building the whole platform and they're doing it. So it'll be for them.
Okay.
So they'll be able to utilize it.
Thank you, thank you. And now, Asisha.
Good afternoon, one and all. My name is Siddharth. I'm from Avantel. So Avantel is a 3-decade-old company, and I'm proud to say that I'm working for Avantel, which is, I would say, a leader in the satellite communication space. So what's the reason? I mean, why satellite communication? Why is it important? So 2 things, right? The first one is self-reliance. So background to that is, I would say 25 years ago during the Kargil War, the US government has blocked satellite communications for our Indian defense. So from then, we wanted to launch our own geostationary satellites and enable self-reliance using our own communication systems. Because in high seas, as well as in other regions close to the border, you wouldn't have 4G, 5G, or 3G network, right? You have to depend on satellite communication systems. So Avantel, working closely with ISRO, SAC, and other entities, we provide satellite communication systems across multiple bands, across all the different various platforms. Some of the applications that we actually have done is the fishing boats, which you have seen in the presentations today. So Avantel provides these 2-way communication data terminals, which are installed in each and every single fishing boat, because the information has to go somewhere to the satellite, and our terminals are the ones which send the data to the satellite and then received over here in the control centers, where strategic information guiding the fishermen as to where you need to go fish, as well as emergency messages where come back. So all this information is happening using satellite communication systems. The other one is, I think there's the tidal gauges and ocean gauges. So all these are very important for tsunami early detections, right? But all these different gauges which are actually in the middle of the ocean, how do you retrieve that data? Again, we have to depend on the satellite communication systems, where our devices are installed on these platforms, where the IoT data is being sent to the satellite, to the control stations, and then you actually do your algorithms and then provide that business benefit. So Avantel is one of the leaders in providing various different satellite communication systems to all the defense forces and other organizations as well. Now, where we are heading as an organization, now we are trying to come out with our own satellite integration facility near Shamshabad Airport as of today. We, along with, I think, Dhruva Space, have received authorization for GSAS applications, ground station as a service, where we want to, again, try to get the data and then get into the end applications as well. And again, I think there's a PPP model which is here, but one of the requirement from the industry is that, unfortunately, as of today, the end customer is the government, because only the government is having the resources to pay for the data. So the government needs to tell us, yes, we will invest whatever it takes to launch our constellation of satellites or a communication satellite with better throughput capabilities. But what's the cost? What do you need? What do you want? What's the type of satellite that we would need to fill the gap? So once we can actually address the business requirement of the Indian government and how much ROI we would be actually getting in terms of recognizing the revenue, we would be willing to invest, launch, and then scale up from there. Yeah. So that's from Avantel.
I mean, so that you will be aware that InSpace is working on such models,
yes,
and there are several schemes coming up. In that, it will be clear how much they can offer. All this thing it will be. But you were talking about that fisherman communication system, and I mean, are you in talk with ISRO to? I mean, if you directly sell those instruments to the fishermen, whether that bandwidth will be available from ISRO. Such kind of discussions, are you progressing?
The project has already been approved, sir.
That is
it's a PM
a
Street
particular
project.
number is there.
1 lakh shipping
1 lakh.
boats, fishing boats have been
In addition,
catered to.
I mean, we have more fishermen boats
Yes.
are there. In addition to that thing,
Yes.
if you can directly sell those instruments, it will be more.
It would again be a government-owned project again because the fishermen, for them to realize the value addition of the services which are being provided, it takes time because they don't really need it, but it's for their safety and we need to make them understand.
Okay.
Second is they would not be able to pay for the satellite costs or the bandwidth that they would be consuming, so it has to be borne by the government as well. So again, like I said, the government has to take that initiative. And for example, 2611, why it's important is 2611 again. We were actually attacked in Mumbai and they came through fishing boats. Now with these applications, you can actually identify who's a friend versus a foe, right? Now the information is available with Coast Guard, the Indian Navy, and hence they can actually easily communicate with them whether they're going past the Indian ocean regions as well, so that they don't get arrested. So all these things are the additional benefits that the government would actually be ensuring that they would be getting.
Thank you, sir.
Thank you, sir.
We'll continue to talk.
Sure, sir.
We will now request Assista to.
Very good afternoon to everyone, distinguished guests and other members here. I'm Abdul representing Azista. I'm very glad to be here to brief on Azista for everyone who know, as well as there are kids and students here. So I would like to definitely let them know. So Azista is a Indian private company. We are satellite mass manufacturers here. So the capacity or the ideology what we have got here is to the one what we have for automobiles, right? Henry Ford moment. Instead of waiting for one car to wait for 6 months, you wanted every car to move out of the factory for every half a day or so. With the same concept, we have come with satellite mass manufacturing. The modular platform what we have established is at least to cater 20 satellite buses per annum. That is the capacity what we have established currently. When I say we can cater 20 satellite buses per annum, it also means we are going to give end-to-end solution. It is not that just the manufacturer. We will do whole manufacturing, EIT process, including the testing required for the whole satellite qualification, may it be EMIMC or vibrations or TVAC cycles. And we do also understand that few of these testings are bottlenecks for mass production, but we have put up the facility in multiple equipments so that there is no bottleneck, and we have addressed majority of things. We launched our own maiden satellite. It's called AFR, Azista Fast Runner. It's been a year last month, June, and this was not a technology demonstration, but capability demonstration that sometimes it is a hiccup, right? The moment you say it's a startup, so how do I rely on? So this was a capability demonstration to show that we were able to not only launch, we have also operated the payloads, and we have beautiful images which I would like to share later on with sir regarding how we have. Apart from this, right, the another major milestone was in discussion was how about the data transfer? How quickly can you get? One of the key challenges, this also we have addressed. We have a X-band transmitter which has up to 1 Gbps throughput. So this helps you for a large amount of data to go on a mere minutes instead of waiting for a couple of contacts over orbits. So this is one of the things. And we make our own payloads. The optical payloads, we make it in-house. Of course, India has been excelling a lot of work in satellite in past decade, in satellite manufacturing, launch, and so on. But I believe a little more activity on semiconductor-related or silicon-related components has been established in India. I think the reliability on foreign vendors or so will drastically come down, and we'll be a lot more Atmanirbhar and self-reliant people very quickly, right? And another thing, we have the data, then what? So, but I would also like to pitch in that we have our own image analytics team. a very good team of around 50 people who does data processing, analytics, and because you have data, I mean, like, as long as you don't get it converted and have it in time, that's of no use. So we have A to Z solutions to provide to any vendor or customer who is requesting these details. Apart from that, one thing I have to really highlight is we not only mix satellites of this cater, we have satellite buses ranging from 50 kilogram payload mass to 400 kilogram payload mass that we can tailor and provide it for any customer.
Thank you.
So
Thank you, Abdul. I mean, in high resolution data, 5-meter resolution, what you're talking, we need a large amount of data for all our application. We need a large. We are only plans for only 3 satellites. That is nowhere near our requirement. So we like to have see the data, and maybe for our government users and all, we like to purchase the data also. That
definitely, sir. Currently, our satellite swath is 70 kilometer. We can, I think, go at least 4 times the current number to provide a much efficient data. Thank you.
And now I request XD Links, Mr. Pramod.
Thank you. Good afternoon to everyone. I am Pramod, representing XD Links. We are basically a 2-year-old company, and we are basically platform provider, end-to-end satellite as a service provider for the end customers. Apart from the satellite service as a service, we also build our own payloads. And there's a strong overlap with three panelists, which I see. So I would restrict myself to be a little whatever distinct which we are trying to do apart from them. So we are currently in the next 2 quarters, we have already launched, and 3 satellites are in the pipeline in the coming 2 quarters. We are waiting for the C-59. So one of the important satellite which is going to be is a communication satellite. It's a nano satellite which is going to operate in E-band, and this is the first time it will be tested in space. And E-band is the new future of the communication, which is going to be a very high throughput band, and then you can go all the way up to 10 Gbps from space. So this is going to be the next generation communication network which can potentially happen. So that is a major milestone for us, and then we are going to test this for the first time in space. So that is coming up in the next quarter or so. And we are also building one more satellite for another startup company, Indian startup company, which is Galaxy, which is the SAR and multispectral payload, which is a challenging platform for which the entire bus is coming from us. So these are the upcoming missions, and we also have a couple of hosted payload projects which are going to happen in the next years. So that will be probably 2025. So coming back to what XD Links is basically we are a company which we say we commoditize space. When we say commoditize space, 2 things, which is affordable and faster realization, which also comes with the standardization as well. So which is modular approach and all that blah blah whatever has been talked about. So from this bus per platform, most of the electronics and subsystems are in-house developed, and most of, I would say 75 to 80% is currently in-house developed, and I would say 90% is indigenous, because a couple of subsystems we are partnering with Indian startups as well. And coming to the payloads, we have sub 4 meter payload multispectral, 1.5 meter GSD multispectral, 0.7 meter multispectral, and the next generation we are having a hyperspectral, which is going to be probably 6 meter. That is what is our roadmap, which we are planning to build in the next 2 years or so.
Okay.
And that is as far as this is concerned. To this audience, probably for the ocean monitoring and other things, we have done one of the hosted payload for the previous mission, where we have put an IoT payload. So what I suggest is, for the monitoring of these, I think the best solution could be to have an IoT payload in the LEO satellites, constellations, which nowadays there are many satellite providers and many satellites coming up, which could be a very good potential case to monitor all the space telemetry, ocean telemetry and everything, which can be real-time monitored and tracked, and for which E-band is also one of the solutions which I would probably use that. Thank you. Thank you for
Thank you, Mr. Pramod. I mean, I see that all of you, Dhruva, Avendal, Assistant, XDS Links, you have got capability to build your own payloads, satellites, and we look forward. I mean, we also now, you know, if you are having the satellites, getting the data is easier. We look forward to get the data. And not only, I mean, I am not talking about from the ISRO side. I am talking from the all user side and also the in situ observation also. Some of you have this drifters or sondes or something. We, instead of getting the instruments, we like to get the data. If you can provide the data, operate these instruments and provide us that quality data, that will be much useful for the user community. There will be people taking this data. Thank you very much. Thank you very much for this very good session.
Thank you, sir. This is lovely.
Okay, thank you. So we'll just move to track 3 now. That's the launch vehicles. And for this, I may invite a representative from Abhyom Space Tech and Defense Private Limited, Agnikul Cosmos Private Limited, and Anand Technologies Private Limited. Yeah.
You are Abhyom?
Most Abhyom Space.
My
name is Rohan.
Yeah, Rohan.
VP of Technology.
Okay. Yeah, Abhyom and Anand Technologies. I mean, now it's rocket science. We are getting into the this thing. Abhyom is, you have the reusable launch vehicles and you are working, and Anand Technologies, you are providing several subsystems for the satellite missions. I'll request Abhyom to speak. I mean, we'll limit within the time.
We'll be quick. Firstly, thank you. Thank you, Incois, and thank you to the degrees for letting us be here and for sharing this platform with us. Firstly, I think everybody must be relieved there's only 2 of us here because it will be done much more quicker. So I will be quick. My name is Rohan Vimal. I'm representing Abhyom Space Tech, and instead of answering what we do directly, I'd like to answer the question how we can contribute to these requirements, and that is how you will know us. I'll be very simple. I want to address the problem statement. The solution that we aim to provide is number 1, reusability, number 2, relaunch times, and number 3, versatility. Just a few elaborative lines on those 3 points. I don't want it to sound like a ChatGPT answer. Number 1, reusability. What we send up, we get back down. All right? We want to save up on the capital that we put in. We want to save up on every payload that goes up so that we can reuse those launch vehicles again and again. Number 2, relaunch times. Today, I think if we go by the statistics that are there, in a year, approximately, we do 12 to 14 launches, if I'm correct. And I think within 5 to 10 years, we aim to get that number 10-fold while still using the same number of launch vehicles, multiple number of times. And our target is to ensure that you have a relaunch time between each subsequent launch of 5 business days. So you launch today, 5 days later, we want to put you in a position to launch your payloads again. And lastly, versatility. From low Earth orbits of up to 200 kilometers altitude, we intend to have an armada of launch vehicles catering from that kind of 200 kgs of payload from LEO to 2,000 kgs of payload in GTO. And we intend to bring that armada of options for you so that payloads of all sizes, shapes, and applications can be used with our launch vehicles, and we don't want to be a restricting measure for you. Today, we want to give you more options. The more supermarkets we have, the more cars we have, the more everything we have, we are at peace. The consumer always wins. And for us, unlike Tier 1 and Tier 2, customers are not an issue because there are plenty, and there's going to be plenty more, as you said, as even sir emphasized, 150 startups, including one of us. So for us, it is important and pertinent that we give you more options in that manner, and this is how we aim to contribute to this question. Thank you.
Thank you. Thank you. Thanks, Mr. Anand. Anand, yeah, please.
Yeah, I'm Naveen Kumar. Now I'm talking about Anand Technologies Limited. Earlier I talked about INRIMT, which is a subsidiary company of Anand Technologies, which purely takes care of all remote sensing applications area. So, see, taking the call from Professor Rao, my chairman came out of ISRO and started this organization with an idea that the Indian space program has got three segments mainly. One is the satellites, another one is the launch vehicles, and the third one is the Earth observation. So we are into all the three segments of Indian space program. So like I already told you, it's three-decade-old company. So ever since we are closely working with ISRO. So far we have contributed to 79 launch vehicles and 99 satellites till date. So we have, ours is the first privately owned company. All AIT facilities are available for end-to-end building of the satellites. We have the capacity and can support up to 4,000 kg class satellites also. That is the capacity we have got. Already we have built. We have three major centers. One is in Hyderabad. Of course, this is our headquarters. Bangalore center is exclusively for satellite programs, and Trivandrum is for launch vehicles. So this is the background of our company, and all our subsystems never failed so far since 1992. This is our track record.
Thank you, sir. Anand Technology, we know very well. We know Anand Technology very well. So, and Abhyom also, wish you all the best. I mean, Abhyom, your efforts, and also we expect a full-fledged launch vehicle from Anand Technology instead of components. We also expect that soon it may be coming out full set of things. Thank you very much. Thank you very much. Because of the time, we will finish it here. Anish, anything to summarize or? Okay, we had we had three streams. We had one on space applications. We had India INRIMT, Adapto, and GeoInfi. GeoInfi was present. Three industries represented, and they were talking about the application segment, what all they are doing, and also what they expect from the community, what they are expecting from the community. Then the second was satellite electronics and communication, Dhruva Space, Avandel, Assist, and XD Links. And all of them have capability to make their own satellite. They are in different stages of it, and now the data will be coming from them. And in the launch vehicle, two industries participated, Abhyom and Anand Technologies. Abhyom is their reusable and rethrottleable launch vehicles are there being made. And Anand Technology is involved in more than 50 components they are providing for launch vehicle, and also for the satellites also several. Inside 3DS they have contributed large number of components and systems they have provided. So this is the total summary of this presentation, this session. I like to close this session here, and thank you very much for this opportunity.
Thank you for the informative and engaging panel discussion, and thank you Dr. Thomas and Dr. Anish for moderating and chairing this session. Parallel to the programs going on here, we have conducted painting and ideathon competitions for the school students. I thank the coordinator, judges, and volunteers for these events, for their immense hard work. Concluding these events, we have a prize distribution ceremony for these competitions. I request Dr. Ravichandran to come on stage and distribute the prize. For painting competition, first prize goes to Miss Sudiksha Gajja, Birla Open Mind School. Second prize goes to Miss Chaitra Shri Thota, Silver Oak School. Third prize goes to Miss Alaina Datta, Birla Open Mind School. For the Ideathon competition, first prize goes to Miss Jayashri Roy, Pay School. Second prize goes to Miss Advita, Little Flower High School. The third prize goes to Mr. Rupeshwar Naidu, Gautami Vidya Kshetra. Thank you, sir. We have had a stimulating day of talks and activities on this National Space Day celebration. I request Dr. Uday Bhaskar to join us on stage to deliver his vote of thanks for today's ceremony.
Yeah, I know I am standing between you and the lunch, so I'll be very brief. Distinguished invitees and delegates, we are now drawing to closure of this National Space Day workshop. I feel it as honor and privilege to propose a vote of thanks on this occasion on behalf of the organizing committee. I would like to extend my sincere thanks to Dr. Harsh K. Gupta, Dr. Sailesh Naik, Dr. Ravichandran, Dr. Prakash Chauhan, and all the dignitaries who have graced the occasion and participated in the inaugural and technical sessions. Thank you, sirs, for making it to the workshop in spite of your busy schedules. I'm grateful to Dr. T. Srinivas Kumar, Director Inquise, for agreeing to host the workshop at Inquise and also for his inaugural address. Thank you, sir. I also thank Dr. Taplial from SAC Ahmedabad, Dr. G.S. Rao, Deputy Director NRSA, Dr. Rajesh NRSA, and all members from ISRO for their guidance and supporting in charting out this program. I thank all industry partners and administrators of various schools and colleges for sending their representatives and students to take part in the activities planned under this workshop. We are fortunate enough to be backed by a team of young, motivated, and dedicated colleagues at Inquise. I would like to extend my heartfelt thanks to colleagues Dr. Balkrishna Nair, Nageshwar Rao, Devendra Kumar, Subramanyam, Rajshekhar, Prasad, Suhasini, and others for taking care of the logistic support and hospitality of the delegates. Last but not the least, the vote of thanks would be incomplete if I fail to acknowledge all those who are involved directly or indirectly in organizing this workshop. Thank you, one and all.
Thank you all for joining us today here at Inquise and making this day a huge success. I thank our speakers and guests, organizers and volunteers. With this, we sign off from this event, and I request everyone to join us for lunch in ITCO Plenary Hall 1.